So, good evening, friends. Today we'll be starting with space science and technology. आज और कल हम ये स्पेस करेंगे. On Sunday we'll be dealing with nuclear science and technology in the first half, and in the second half we'll cover robotics and nanotechnology. Okay, उसके बाद हमारा एक जो मेजर टॉपिक बच जाता है that will be computer, IT and electronics that we would do next week. Next week हमारा science and tech खत्म हो जाएगा पूरा. After that, in January itself, we will solve 500 questions on science and technology. To revise entire science and technology with the help of 500 questions, that is our RTFQ series, revised through 500 questions series. Now, because we are going to solve a lot of questions there, यहाँ पे मैंने number of questions थोड़े कम रखे हैं. Like today, we'll only be dealing with 20 questions because we'll solve on space, on astronomy, and on electromagnetic waves. This time I've added electromagnetic waves as a detailed content in space wala booklet only, where we'll talk about different types of electromagnetic waves, कौन से अर्थ तक पहुंच पाते हैं, कौन से नहीं पहुंच पाते, what is the function of radio wave, what is the function of microwaves, what is the function of infrared, how they are generated, visible light, ultraviolet, X-rays, gamma rays. We would talk about all those aspects in this booklet only. We'll deal with here only. So on these topics, on these three topics, space, astronomy and electromagnetic waves, in RTFQ we will be solving 100 questions. So just because there are only 20 questions here, do not assume कि number of questions that would be discussing here would be lesser. ठीक है, तो आज शुरू करें space. Okay. आज थोड़ी गर्मी ज़्यादा है. ये आप इंडेक्स देख के समझ ही सकते हैं कि कितनी सारी चीज़ें हमें कवर करनी है. In space, a general structure would be, first we'll talk about some basics of space science and technology, like how orbits function, how rocket functions. We'll talk about those basics. Then we'll jump onto Indian initiatives in the field of space. After that, we will cover international initiatives in the field of space. Okay, what is NASA doing, what is China doing, what is Russia doing, all those stuff. After that, we will go to other general astronomy issues like black holes क्या होते हैं, what is their role in understanding the universe, what is the we'll talk about sun, various features of sun, solar storms, like last year solar storms वाला सवाल आया था. We'll deal with those aspects and then electromagnetic waves. तो पहले हम शुरू करेंगे ऑर्बिट से. We will be starting with orbits. At very basic level, what is orbit? Orbit is the path, like if it is Earth, the path which the satellite takes to revolve around Earth. This is the orbit at very basic level. When a satellite is revolving around Earth, like let's say when Moon is revolving around Earth, what is the force which is making Moon continuously revolve around Earth? It is the gravitational force. We all understand that. Okay, so if you have studied physics in class 11, you would have studied this. If you want to, let's say there's a piece of stone, and if you want to revolve that stone around you, आप कई बार रस्सी बांध के एक stone को revolve करते हैं. तो if you want that एक mass m revolves in a radius r at a speed v around you, then the force that you'll need to apply, जो उस रस्सी पे the force that you need to apply is equal to mv square by r. This r, right? So you do not have to remember this formula or anything like that. I'm just coming to a quick conclusion कि orbit में जब when moon is revolving around Earth or when other satellites are revolving around Earth, if they are revolving at a distance r from the center of Earth and at the speed v, at the velocity v, तो उन पे force जो gravity का लगना चाहिए, that should be mv square by r, where small m here is the mass of the satellite. It can be mass of the moon or mass of let's say GSAT or mass of any other satellite of Earth, right? And what is the force of gravity? Gravity का force होता है g m by r square, where m is the small mass, ये capital M is the mass of Earth. So this is the force of gravity, और इतना force चाहिए. This should be equal to this. राइट। इससे जब हम सॉल्व करेंगे तो वी विल गेट दिस की वेलोसिटी इज इक्वल टू अंडर रूट GM बाय, विल नॉट गो इनटू सॉल्विंग इट कि कैसे सॉल्व होगा, बट वो नॉर्मल इक्वेशन सॉल्व करके है, बट वेलोसिटी वुड बी अंडर रूट GM बाय R, where G is the gravitational constant, M is the mass of Earth, and R is the radius at which this satellite is revolving. R is the radius at which this satellite is revolving. Notice something, यहाँ पे mass of satellite कोई role play कर रहा है? No. Mass of satellite is not playing any role at all. So no matter, like if this is Earth, and at R radius, let's say this is a circular orbit at a radius of R. No matter how small, how large a satellite you put there, its velocity would be under root GM by R. ये सबको समझ में आया? Does it make sense? पक्का है ना? So now notice one more thing. Here R is in the radius. R is in the radius मतलब as the R increases, velocity decreases. As the R, let's say हम इस बड़े ऑर्बिट में जाते हैं, here the velocity of the satellite would be smaller because R is in the radius and R has increased. Here the velocity of satellite would be smaller. आपने तो PMP में भी किया है, नहीं किया? Okay. Here the velocity of satellite would be smaller. Are we all understanding this? पक्का? So notice one more thing. A satellite is revolving in smaller radius. उसका speed ज़्यादा है, v is equal to under root GM by R, and the distance it has to complete one circle is lesser. This 2 pi R will be lesser than this 2 pi R. इसका speed ज़्यादा है, distance कम करना, distance that it has to cover is lesser. What does it mean? It means that it will take much smaller time to complete one circle. It will take much smaller time to complete one circle. Right? ये मेरे ही रिव्यू, मेरे ही ऑनलाइन, अरे क्लास देख के रिव्यू ले लो ना, वो दूसरे बच्चों से रिव्यू मांग रहे हैं लाइव चैट में। क्लास देख लो, दूसरे बच्चे, देखो ऐसा हो सकता है ना, दूसरे बच्चे फेक भी होते हैं, ऑफिशियल हमारे ऑफिस की तरफ से लोग बैठे हों जो आपको फर्जी रिव्यू दे रहे हों। When you look for these kind of reviews on Telegram channels, on Quora, most of the institutions have their people planted in there. So you watch classes and then take a call on this, rather than doing anything random ki you're asking some random person. If you know some close friend, वो अच्छे reviews देंगे, but जो random online reviews होंगे ना, आप Quora पे जाके reviews देखोगे, इतने बढ़ा चढ़ा के कुछ भी लिखा हुआ है, पढ़ाते पढ़ाते कुछ है, ऐसा है, बहुत सारे पेड रिव्यूज लिखे होते हैं। तो डोंट गो बाय दैट, यू योरसेल्फ वॉच द क्लास और यू हैव समवन क्लोज टू हेल्प यू आउट, टू एक्सप्लेन यू कि ये इंस्टीट्यूशन अच्छा है या नहीं, उनका रिव्यू लो। अदरवाइज जिनके पास ज़्यादा पैसा है वो ज़्यादा मार्केटिंग कर सकते हैं, ज़्यादा लोगों को हायर कर के ज़्यादा कोरा रिव्यूज लिखवा सकते हैं। ओके, एनीवेज, डिड वी अंडरस्टैंड दिस कि इफ अ सैटेलाइट वुड बी रिवॉल्विंग इन स्मॉलर ऑर्बिट, वो तेज भी चल रहा होगा और वो कम टाइम में एक सर्कल खत्म करेगा। इफ अ सैटेलाइट वुड बी मूविंग इन लार्जर ऑर्बिट, वो धीरे चल रहा होगा एंड इट विल टेक मच लार्जर टाइम टू कंप्लीट वन ऑर्बिट। ये बात समझ में आई? सो इफ यू कम हियर, ग्रेविटी एंड द स्पीड ऑफ सैटेलाइट इन द ऑर्बिट, डिड यू अंडरस्टैंड दिस? है ना, स्पीड ऑफ सैटेलाइट वुड बी डिपेंडेंट ऑन ग्रेविटी। अगर ग्रेविटेशनल फोर्स बढ़ जाता है, स्पीड बढ़ जाएगा। नाउ थिंक ऑफ दैट स्टोन दैट यू आर रिवॉल्विंग अराउंड यू, इफ यू इंक्रीज द फोर्स दैट यू आर अप्लाइंग, विल इट स्पीड इंक्रीज? Its speed would increase. If you slow it down, it would decrease. Right? Same is the case here. With higher gravity, more would be the speed at which it will be revolving. And gravity का फॉर्मूला है gmm by r square, जहां r रेडियस में है, तो जैसे ही आप किसी ऑब्जेक्ट से दूर जाओगे, their gravity would keep reducing. Okay, got it? ये सबको समझ में आया? So this is also understood, gravity and speed of satellite. Now, how are satellites placed in orbit? That is another aspect. Let's say we want to launch a satellite, ये अर्थ है, and we want to launch a satellite at a radius r. Please note, कई बार हम radius r बोल रहे होंगे, but most of the time we'll be talking about height from the surface of earth. So at that time, what would be the radius? Height plus 6400 kilometers. 6400 is the radius of the earth, है ना? So do not get confused when I sometimes use r and sometimes only use h. H is r minus r plus r minus 6400. This is the radius of earth. The entire radius would be the 6400 plus h. Right? ये बात समझ में आई है? So generally we will be using h, but sometimes when we talk about GMM by r square, we are using the entire r of the satellite, not r of the earth. Fine. Now, suppose we want to launch a satellite at a height h or at a radius r, same, at a height h or at a radius r, इसे बड़ा r बोल देते हैं. Let small r represent the radius of earth, which is 6400 kilometers. So what do we need to do? If we take a satellite here and just leave it, will it start revolving? No, it won't start revolving. It will fall back on earth. Right? कोई भी stationary object आप ले जाके बस ऊपर height पे छोड़ दोगे, will it be enough for satellite to revolve? No, it won't be. You'll have to give it some horizontal speed. Else, gravity will pull it towards itself. Right? You'll have to give it some horizontal speed. So when you take a satellite to a particular height and then you launch it with a speed v. Now three things may happen. The v may be very less and it eventually falls back on earth because earth's gravity is pulling it towards itself. Right? Or v may be, this v may be, let's say this bigger r is r, and the v with which you launch it, velocity with which you launch it, is exactly equal to under root gm by r. This velocity is exactly equal to under root gm by r. So if you launch it with velocity less than under root gm by r at a height, at a radius r from the center of earth, it would fall back. But if you launch it with a velocity of exactly equal to under root gm by r at a height or at a radius r from the center of earth, it would go in a circular orbit. It would go in a circular orbit where the radius from the center of earth would remain r. The radius from the center of earth would remain r. Did we understand this? Did we understand this? Pakka? Sure? So, if we are launching at velocity less than under root gm by r, what happens? Orbit hoga hi nahi. If we are launching at velocity exactly equal to under root gm by r, what happens? It orbits in a circular path where the radius remains r throughout. Velocity remains under root gm by r throughout. At this speed, what balances this? ऐसे समझो, हम इसे horizontally launch कर रहे हैं, तो अगर कोई force नहीं होता, it would have moved in this direction only, but earth is pulling it in this direction. Earth is pulling it downwards. तो let's say जब ये यहाँ से यहाँ move हुआ, earth is again pulling it downwards, so it wants to move horizontally, but earth is pulling it in this direction. It would slightly bend, resultant, slightly bend, and thus it remains in a circular orbit. So at v less than under root gm by r, it falls back on earth. At v is equal to under root gm by r, it remains in a circular orbit. But what happens when we launch it at a speed more than under root gm by r? What happens when we launch it at a speed more than अंडर रूट GM बाय R। जब हम इसका जो हॉरिजॉन्टल वेलोसिटी है वो हमने अंडर रूट GM बाय R से ज्यादा दिया, इनिशियल वेलोसिटी। इनिशियली व्हेन वी आर लॉन्चिंग द सैटेलाइट, व्हेन वी लॉन्च इट एट अ स्पीड मोर देन अंडर रूट GM बाय R, इन दिस केस व्हाट हैपेंस इज, इसका हॉरिजॉन्टल वेलोसिटी ज्यादा है। देखो, टू अंडरस्टैंड दिस प्रॉपरली, अर्थ at a radius r, you are launching it horizontally. Initially you are launching it horizontally at a speed more than under root GM by R. अगर वो exactly under root GM by R होता तो क्या होता? It would have gone in a circle. If it was less than under root GM by R, it would have fallen back on Earth. But if it is more than under root GM by R, what happens at this time? Now note this: Earth is pulling it towards in this direction. Its momentum, its initial momentum will try to take it in this direction, है ना? At exactly under root GM by R, balance was maintained in such a way that it remained a circle. But at this time, इसका horizontal speed is higher, horizontal velocity is higher initially, तो balance वो सर्कल वाला नहीं बनेगा, जो सर्कल वाला पहले बन रहा था ना। यहाँ पे क्या होगा? Its horizontal movement would be higher when compared to its vertical movement in the initial phases, and it would go something like, it goes in the elliptical orbit. It goes in the elliptical orbit. Right? Why? देखो, अगर V was exactly under root GM by R, तो ग्रेविटेशनल फोर्स का इस डायरेक्शन में उसे पुल करना और उसका जो हॉरिजॉन्टल वेलोसिटी है, that would have balanced in such a manner that it would have remained in a circular orbit. But here when the horizontal velocity is higher, वो बैलेंस नहीं कर पाएगा, तो it will go further ahead. It will go further ahead, right? So here its R would change. In an elliptical orbit, R तो सेम नहीं रहेगा. Here R1 would be much higher. Here R2 would be सबसे ज्यादा, right? So what is the force being applied? Under root GM by R. So please note that यहाँ पे velocity, what is the force being applied? GMM by R square. R बदल रहा है, तो अर्थ का फोर्स भी सैटेलाइट पे बदल रहा होगा. As force would change, speed would also change, है ना? तो यहाँ पे speed would be different than यहाँ पे speed. Speed would be what? Or velocity would be what? Under root GM by R. Here R is much higher, velocity would be much smaller. So in a circular orbit, the satellite was moving with a uniform speed, but in an elliptical orbit, satellite's speed would keep changing. Here it would be under root GM by R, here it would be under root GM by some other R. Velocity would be under root GM by R, but R would change. Here R is different, here R is different, here R is different. So under root GM by R thing would be different throughout. ये बात समझ में आई? Now do you understand how does satellite get launched in circular orbit? How does it get launched in elliptical orbit? Did we understand this? Okay. Clear है? Okay. Now, this I have explained you orbital velocity circular versus elliptical में. For a circular orbit, its velocity would always be the same, but for elliptical, it would keep changing. Now we'll talk about types of orbit. Fatafat, we are going because we have to cover lots of things in 2 classes. तो थोड़ा जल्दी चल रहे हैं, तो थोड़ा concentrate ज़्यादा करिए, focus से पढ़िए. Stupid silly doubt मत पूछिएगा. अगर आपको लगता है genuinely कि this is an important doubt, then go for it. Else, अच्छा पूछो, डाउट पूछो, बट ट्राई टू एंश्योर कि वो कोई बहुत ही वाहियात सा डाउट ना हो और हम टाइम वेस्ट ना कर रहे हो. एक सेकंड दे दीजिए. हाँ बताइए. जी नहीं हर वेलोसिटी के लिए करेगा. अच्छा ऐसे बोलो सर मुझे डाउट है, रादर देन कि ऐसा नहीं करेगा. हाँ, आप एस्केप वेलोसिटी पे लॉन्च कर दोगे तो इट विल एस्केप द अर्थ ग्रेविटी. नहीं अब देखो फिर से समझो, ellipse would change, ellipse will not be of one type, ellipse would change, but elliptical velocity, elliptical वो at v more than under root gm by r, it would go in elliptical velocity. Now in what ellipse do you want to launch, उसके बेसिस पे आपको एक पर्टिकुलर v इनिशियल देना पड़ेगा, समझो इसे. बट एलिप्स में चेंज विथ योर वेलोसिटी, इनिशियल वेलोसिटी चेंजिंग, एलिप्स में चेंज. आपने एलिप्स को एक पर्टिकुलर एलिप्स मान लिया तो उस पर एक पर्टिकुलर वेलोसिटी चाहिए होगी, बट अलग अलग एलिप्स हो सकते हैं ना, राइट? समझ में आया? तो डाउट के फॉर्म में पूछो रादर देन ऐसा नहीं होगा, राइट? चलिए, यस इवेंचुअली वेलोसिटी यहाँ पे लोवेस्ट हो जाएगी. वेलोसिटी देखो एक चीज समझो, वेलोसिटी के साथ ना डायरेक्शन भी एसोसिएटेड होता है, इट्स अ वेक्टर टर्म, तो हम स्केलर बोलते हैं. स्पीड वुड डिक्रीज इवेंचुअली, हियर स्पीड वुड बी वेरी हाई व्हेन इट इज क्लोजेस्ट टू अर्थ, स्पीड वुड बी वेरी हाई, एंड व्हेन इट इज फर्देस्ट अवे फ्रॉम अर्थ, स्पीड वुड बी वेरी लो. फॉर सर्कुलर ऑर्बिट इट रिमेन्स सेम, इट रिमेन्स सेम अंडर रूट gm by r. ऑब्स्ट्रक्शन आ गया तो फिर तो बदल गया ना. ऑब्स्ट्रक्शन की बात नहीं कर रहे हैं अभी. अगेन देखो ऑब्स्ट्रक्शन की बात करते हैं अभी हम, उसमें आएंगे, जब बहुत सारा वेस्ट हमने स्पेस में क्रिएट कर दिया उसका क्या इंपैक्ट होता है वो सब पढ़ेंगे. बट फॉर नाउ अज्यूम दैट दिस इज अर्थ एंड देयर इज ओनली वन सैटेलाइट, है ना? वी आर टॉकिंग फ्रॉम दैट पर्सपेक्टिव. ओके, तो सर्कुलर ऑर्बिट वाली बात समझ में आई. नाउ समवन इज आस्किंग सर इसका मतलब स्पीड हमेशा मेंटेन करके, स्पीड हमें नहीं मेंटेन करना. स्पीड because it is Earth's gravity which is supplying the force, so speed would remain under root gm by r there in the circular orbit. Sometimes because of some external factor some deviation occurs, and at that time we make some changes in the orbit of the satellite to bring it to the exact orbit, exact speed where it should be. Okay, in ideal world we do not have to do anything, but the world is not ideal, there are a lot of other aspects. ओके, ये बात समझ में सबको आ गई है? सबके तीन तीन डाउट है देख रहा हूं मैं, एक 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 हो गया है. हाँ बोलो. यस, इट विल नेवर रीच बिलो अंडर रूट gm by r. नो 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 नो, इट वोंट. देखो आप इनिशियल लॉन्च वेलोसिटी की बात हो रही है, नॉट वो. दूसरी बात समझो कि इवेंचुअली यहां पे इसकी वेलोसिटी वुड बी अंडर रूट gm by r, वो जो इसका r है हर जगह वो रहेगा, राइट? बट बिकॉज इनिशियल लॉन्च वाज ऑफ सम अदर फॉर्म, इट रिमेन्स द अदरवाइज. ओके, लेट्स कम टू दिस ऑर्बिट. अब हम टाइप्स ऑफ ऑर्बिट की बात करेंगे बिकॉज आवर सैटेलाइट्स आर लॉन्च्ड इन different orbit. So first we would divide orbits into two broad types. One is circular orbit, जहां पे radius remains same. One is elliptical orbit. Do we understand how satellites are launched in circular orbit and how they are launched in elliptical orbit? Now we would divide circular orbits into four different types. We'll divide circular orbits into four different types. Notes आप सबके पास हैं? क्यों नहीं है? अच्छा, कितने लोगों के पास नहीं है नोट्स? अच्छा, अभी आ रहे हैं. और स्टूडेंट्स फॉर वाचिंग इट ऑनलाइन प्लीज कीप नोट्स विद यू. नोट्स में सारी चीजें लिखी हुई हैं, तो यू जस्ट हैव टू फोकस हियर ऑन अंडरस्टैंडिंग. ओके, डू नॉट लाइक आई गिव नोट्स सो दैट आपका फोकस समझने पे हो, या ना कि सब कुछ नोट डाउन करते रहने पे. व्हेन यू डू दैट एट दैट टाइम योर फोकस रिड्यूसेस स्लाइटली. तो यहाँ पे पूरा फोकस समझने पे रखेंगे. जो बच्चे हमारे स्टूडेंट्स नहीं है फिर भी देख रहे हैं, even for them I have provided the notes for this live class. In the description you have a telegram channel link, there you will be able to get the notes. Okay, let's come back to this. What were you talking about? Types of orbit. Types of orbit, there are two types of orbit, elliptical orbit and circular orbit. Now circular orbits also, circular orbit do we all understand, jahan pe radius r would remain same. Circular orbits can further be divided into four types. Okay, let's understand. अब मैं अर्थ छोटा सा बना रहा हूं. दिस इज माई अर्थ, लेट मी कलर इट विद ब्लू. Now see, when I launch a satellite around it, at a radius r with a speed with the initial velocity under root gm by r, what happens? It remains in a circular orbit. It will remain in a circular orbit, right? Earth is a gmm by r square se खींच रहा है, it will remain in a circular orbit. But at lower height, let's say at a height of 20 kilometers, Earth का atmosphere is quite dense, so Earth का atmosphere will oppose this rocket. Earth का atmosphere will oppose this rocket or this satellite. Satellite, by the force of gravity, would have remained in a circular orbit. Satellite, because of the force of gravity, would have remained in a circular orbit when we launched it initially with the speed of under root gm by r. But because क्या हो रहा है? अच्छा ठीक है because of under root gm by because of Earth's atmospheric density being high, that its movement would be opposed by atmosphere. When its movement gets opposed, what happens? It slows down. And when it slows down, what would happen? Eventually, its speed would become less than under root gm by r. It would fall on. तो जहां पे अर्थ का एटमॉस्फेयर इज डेंस इनफ, वहां पे वी वोंट बी एबल टू लॉन्च सैटेलाइट. तो फ्रॉम अ हाइट ऑफ 0, अब मैं हाइट की बात कर रहा हूं, नॉट रेडियस. रेडियस में 6400 यू विल ऐड. फ्रॉम अ हाइट ऑफ 0 टू a height of 160 kilometers, you cannot launch a satellite because here Earth's atmosphere is dense enough that it will oppose the movement of the satellite. From a height of 0 to 160 kilometers, you cannot launch a satellite because Earth's atmosphere will slow down. No matter at what speed you launch the satellite would eventually be slowly slowed down and it would fall back on. एक ऑर्बिट, 2 ऑर्बिट, 3 ऑर्बिट, 4 ऑर्बिट के eventually it would fall back on Earth. The path may not exactly be the same. Path may be something like this, but eventually it will fall back on Earth. So we cannot launch satellites at a height below 160 kilometers. तो कभी आप देखते हैं ऐसे 10 किलोमीटर ऊपर सैटेलाइट घूम रहे? नो. Satellite can only be launched at a height higher than around 160 kilometers. So from 160 kilometers to a height of 2000 kilometers. From 160 kilometers to a height of 2000 kilometers, when a satellite is launched in a circular orbit, it is called low Earth orbit. From a height of 160 kilometers to 2000 kilometers, the satellite is called low Earth. The orbits would be called low Earth orbit. Did we all understand this? अब देखो low Earth orbit में what will be the speed when compared to other orbits? Higher. अच्छा पहले ये समझ लेते हैं. This low Earth orbit, did we understand? From 2000 kilometers to 35786 kilometers. Or roughly we also write it as 36,000 kilometers. This orbit is called medium Earth orbit. This orbit is called medium Earth orbit. The height of exactly 35786 kilometers. The exact height है ना 357. That particular height only. This exact height of 35786 kilometer is called geosynchronous orbit. Geosynchronous orbit. GEO synchronous orbit. Notes में लिखा हुआ है. And then orbits beyond this will be called high Earth orbit. So we have divided orbits into 4 types. First we divided orbits into circular orbit and then elliptical orbit. Circular orbits ko we have divided into low Earth orbit, which goes from 160 kilometers to 2000 kilometers. Then medium Earth orbit 2000 kilometers to 36,000 kilometer or 35786 kilometer. Geosynchronous orbit 35786 kilometer exactly, and then high Earth orbit beyond 35786 kilometer. Why this division? We'll understand this. What is the purpose of this division? We would understand that. So first, let us start with low Earth orbit. समझते हैं लो अर्थ ऑर्बिट वाले एस्पेक्ट को, लो अर्थ ऑर्बिट वाले कॉन्सेप्ट को. देखो, एक तो हाइट क्या वो समझ में आ गया, राइट? डू वी अंडरस्टैंड दिस कि टाइम टेकन बाय सैटेलाइट टू कंप्लीट वन रेवोल्यूशन इन लो अर्थ ऑर्बिट would be much lesser than the time taken by satellite to complete one revolution in medium Earth orbit. Do we understand this? So when we do calculation, we find that at a height of 2000 kilometers, a satellite takes 2 hours to complete one revolution. At a height of 2000 kilometers, the satellite takes 2 hours to complete one revolution around Earth. ये बात समझ में आई? तो at a height below 2000, will it take even less than 2 hours? Will it take even less than 2 hours? Yes. तो जनरली जब आप ऐसे 500 किलोमीटर की हाइट पे एक सैटेलाइट को लॉन्च करते हो ना, तो इट टेक्स ओनली अराउंड 80-90 मिनट्स टू कंप्लीट वन रेवोल्यूशन. लेट्स से मैं अर्थ हूं, ये सैटेलाइट है, इट इज रिवॉल्विंग अराउंड मी, है ना. इफ द हाइट इज 2000 किलोमीटर, तो ये 2 घंटे में एक चक्कर लगा लेगा पूरा, और अर्थ 2 घंटे में कितना, थोड़ा सा ही रोटेट हुआ होगा. अर्थ टेक्स 24 आवर्स टू कंप्लीट वन रोटेशन. तो बाय द टाइम I complete one rotation, it would have revolved 12 times. That too when it is at a height of 2000 kilometers. But when it is a height lesser than 2000 kilometers, it would have taken much higher number of orbits. है ना, 15, 16, 17, 18 बार घूम लिया होगा, right? Depending on at what height it is. Did we understand low Earth orbit? Now, what kind of satellites do we put in low Earth orbit? इसको समझते हैं. General देखो, if you have to observe Earth, you will try to take pictures from as near as possible. So generally, Earth observation satellite, where you are taking images, where you are observing the Earth. Generally, the remote sensing satellite. Remote sensing means दूर से अर्थ को देखना, दूर से सेंस करना. When you are using remote sensing satellites, when you are using Earth observation satellites, when you are using satellites which are used for making maps, that would be put in low Earth orbit. Those would be put in low Earth orbit. Why would those be put in low Earth orbit? Because पास में से अर्थ अच्छा साफ दिखेगा. As you move away, you will be able to get lesser and lesser visibility. Right? Are we all able to understand this? Sir, please upload notes a little early before. I uploaded it 1 hour before class, no? 4 बजे मैंने अपलोड कर दिया था, 4 बजे ग्रुप में डाल दिया था. Sir, why is this division restricted to circular orbit? Because बेटा elliptical orbit में तो radius changes, no? तो same orbit would be at one point at a height of 300 kilometers and another point at a height of 40,000 kilometers. Elliptical orbit तो ऐसे हो सकता है ना. That is why we are restricting this division to सर्कुलर ऑर्बिट. चलिए, आई होप उनके डाउट से ये समझ में आया. कौन से सैटेलाइट्स यहां जाएंगे ये भी समझ में आया. जनरली द अर्थ, जनरली आई एम यूजिंग जनरली, नॉट ऑल. अब आपका मन है अर्थ ऑब्जर्वेशन सैटेलाइट ऊपर डालने का, डालो, है ना. जनरली द अर्थ ऑब्जर्वेशन सैटेलाइट्स वुड गो हियर इन लो अर्थ ऑर्बिट. और क्या हो सकता है? द सैटेलाइट्स व्हिच आर यूज्ड फॉर satellite phone communication also go in low Earth orbit. Now to understand this, let's consider this Earth, and there are areas where normal phones are not available, telephone towers are not there, and there you have to use satellite phones. Now satellite phones, like army uses satellite phones, है ना. Now if they are using satellite phones and if a satellite is nearby, then they would be able to send signal and someone else would be able to receive signal. and this time taken would be lesser. Real time communication somehow may be possible, right? But if it is a height of 36,000 kilometers, at that time ये सिग्नल 36,000 किलोमीटर पे जाएगा, फिर वहां से रिफ्लेक्ट होकर दूसरे के पास आएगा, it would take a lot of time. So some communication satellites, which kind of communication satellite? Like satellites which are used for satellite phones are also used here. Satellite phones में थोड़ा सा गैप रहता है because they have to travel this 500 kilometers and 500 kilometers का distance, and that is why you would see armed forces using this kind of mechanism, alpha to Charlie, फिर over. When they say over, only then the other person starts speaking. When the other person has received complete, they cannot speak like us कि बीच में लड़ रहे हैं तो क्या कर रहा है, they cannot, else सब overlap हो जाएगा. Understand the reason. One of the person completes the statement, the communication reaches the other person, उसने पूरी statement सुन ली, then the other person starts speaking, because the communication is not real time and not exactly real time, थोड़ा सा gap रहता है because they have to. So if the satellite was at a much higher height, this gap would have been much higher, right? So why, which kind of communication satellite can be in low Earth orbit? Satellite phones वाले communication satellite, or you can also put some other communication satellites, ठीक है. But are you understanding the reason? Then generally when we go for human space flights, human space में जा रहे हैं, so other than the Apollo mission which took humans to moon, what is the height of moon from Earth? Around 3.5 lakh kilometers. बहुत दूर है moon. So other than the Apollo programs which took humans to moon, USA का Apollo program took humans to moon. Other than that, when humans have gone into space, they have only gone to low Earth orbit. When humans have gone to space, they have only gone to low Earth orbit. For example, when scientists go to International Space Station, International Space Station is at what height? 400-500 kilometers, around 450 kilometers के आसपास है, 350 something like that. So it is in low Earth orbit. China has recently, in your notes today, we have covered Chinese initiatives also. China have also recently launched a space station. Where has the space station been launched? In low Earth orbit. India is planning to launch a space station. Where would India's space station be launched? In low Earth orbit. So, do we all understand what low Earth orbit is? Generally, the Earth observation satellite, because you can better observe the Earth, would be put in low Earth orbit. Some kind of communication satellites can also be put in low Earth orbit. Like satellite phone communications के लिए the low Earth orbit is more suitable. And then finally, what kind of satellite? What was the third satellite that what was the third kind of thing? The space station, international space stations generally are in the low Earth orbit only. Did we all understand what low Earth orbit is? पक्का? Okay. एक ये गेट खुला रखना है मेरी क्लास में, सफोकेशन हो जाएगा, नहीं तो खोल दीजिए, उठ के दोनों स्लॉट खोल दीजिए, कोई कुछ चाहिए. ओके, तो all human space flights, all manned mission, let's cover its main characteristics. Low Earth orbit when a satellite is put, what are its main characteristics? Orbital period is low, less than 2 hours, orbital period. User and satellite are closer. User and satellite are very close to each other, so latency would be very less. Earth observation satellites can also go there because they are closer to each other. Radiation levels are also lower. जो सन से रेडिएशन आता है, सोलर फ्लेयर्स आते हैं, Earth's magnetic field repels them, do not allow them to come to the surface of Earth. So satellites in low Earth orbit do face some of those radiations, but in lesser quantity. Satellites in higher orbits will face much higher amount of those radiations. Are we all understanding this? ओके, हम आज सोलर फ्लेयर्स और सोलर स्टॉर्म्स इन सब के बारे में और डिटेल में पढ़ेंगे. देन प्लेसिंग सैटेलाइट इज इजी हियर. व्हाई? योर रॉकेट विल टेक द सैटेलाइट टू दैट हाइट, So if the height is nearer wala, for your rocket, less effort would be taken. If the height is much higher, for your rocket, much more efforts would be taken to take that satellite to higher distance. So it's easier to place a satellite here, and finally lower latency for communication, and that is why satellite phones may we are able to use it when compared to other orbits. Are we all able to understand this? Okay. Then application देखिए तो अर्थ मॉनिटरिंग सैटेलाइट, अर्थ ऑब्जर्वेशन सैटेलाइट, कम्युनिकेशन सैटेलाइट्स, इंटरनेशनल स्पेस स्टेशन इज ऑल्सो हियर. नाउ इन मितेश मेरे लिए एक काम करोगे, इस वाले रूम में ना एक वो रखा हुआ है ग्लोब, लेके आ जाओ. व्हेन वी आर टॉकिंग अबाउट लो अर्थ ऑर्बिट, लो अर्थ ऑर्बिट का एक स्पेशल टाइप होता है सन सिंक्रोनस ऑर्बिट. एक स्पेशल टाइप ऑफ लो अर्थ ऑर्बिट इज sun synchronous polar orbit. Generally the earth observation satellites go in sun synchronous polar orbit. Thank you. Now what is sun synchronous polar orbit? Let's first understand this. What is sun synchronous polar orbit? SSP, sun synchronous polar orbit क्या होता है? So first let's understand what is polar orbit. Polar orbit is nothing but, ये अर्थ है, ये उसके पोल्स हैं. When a satellite is generally moving from pole to pole, है ना. पोलर मतलब exactly 90 डिग्री ना होके थोड़ा बहुत इधर उधर हो सकता है, but when a satellite is moving from pole to pole, it is polar orbit. It's simple. It's as simple as that. Now let's understand what is meant by some satellite being called sun synchronous polar orbit. Sun synchronous होने का मतलब क्या है? It is in sync with sun. Sun synchronous orbit or sun synchronous polar orbit. Now, what is the sun synchronous polar orbit? Generally, we would see that most of our Earth observation satellites are launched in sun synchronous polar orbit. Most of our Earth observation satellites are launched in sun synchronous polar orbit. आज इसका बहुत नुकसान हो गया, आज नहीं आएगा बेटा समझ में आपको आगे. क्या आप इकोनॉमी ऑप्शनल की क्लास में बैठ के इसका लेक्चर देख रही थी? अच्छा देखा है, ओके ओके, फिर आ जाओ, फिर ठीक है. नहीं तो द फर्स्ट 1 hour ऑफ टुडेज सेशन विल बी यूज्ड इन एवरीथिंग इन दिस एंटायर बुकलेट. हम एक एक कॉन्सेप्ट जो पढ़ेंगे ना आगे का, जो भी बेसिक्स पढ़ रहे हैं वो समझना बहुत जरूरी है. इफ यू डोंट अंडरस्टैंड दिस, आगे की चीजें समझ में नहीं आगे, बस फिर एवरीथिंग वुड बिकम फैक्चुअल इफ यू ऑलरेडी अंडरस्टैंड दिस. ओके, दैट्स व्हाई जो भी बच्चे बीच में भी आ रहे हैं यूट्यूब पे, वो शुरू से देखना शुरू करें इस लेक्चर को, रादर देन स्टार्टिंग फ्रॉम बिटवीन. तो लेट्स कम टू सन सिंक्रोनस पोलर ऑर्बिट. डिड वी अंडरस्टैंड व्हाट इज पोलर ऑर्बिट? नाउ सी, लेट्स से एक हाइट है 500 किलोमीटर और 600 किलोमीटर फ्रॉम द सरफेस ऑफ अर्थ. उस पे एक हम सर्कुलर ऑर्बिट बनाते हैं. इनफैक्ट लेट मी टेक दिस. लेट्स से ये सिनेरियो है, यहां पे सन है, राइट, यहां पे सन. नाउ a satellite is revolving from pole to pole in this direction. If it's at a height of 400 kilometers, what would happen? ये अर्थ थोड़ा सा ही मूव हुआ होगा, सैटेलाइट इन 90 मिनट्स वुड कम बैक अगेन. फिर अर्थ थोड़ा सा ही मूव हुआ होगा, सैटेलाइट इन 90 मिनट्स वुड कम बैक अगेन. थोड़ा सा मूव हुआ होगा, सैटेलाइट इन 90 मिनट्स वुड कम बैक अगेन, राइट. इन 24 आवर्स रफली मतलब कितनी बार आ जाएगा? 90 मिनट्स में होता है तो 1.5 divided by 24, 16 times. 24 divided by 1.5 is what? 16, right? सी साइड भी देना है ना, 18, 16 आएगा, हाँ 16 आएगा. चलिए, तो 16 टाइम्स ही घूम जाएगा. बट व्हेन अ सैटेलाइट इज इन सन सिंक्रोनस पोलर ऑर्बिट, then when a satellite is in sun synchronous polar orbit, at that time what has to happen? अच्छा, बाय द वे इस चीज को समझो कि if sun is on this side, this is the month of December. Do we understand this? क्योंकि southern hemisphere is towards the sun. राइट जब ये इस तरफ पहुंच जाएगा तो विल बी इन द मंथ ऑफ जून, नॉर्दर्न हेमिस्फीयर वुड बी टुवर्ड्स द सन, राइट। ये बात समझ में आ रही है। तो अभी हम दिसंबर में, सन इज हेयर, अभी हम दिसंबर में है, सन इज हेयर एंड satellite is revolving. What is meant by a satellite being in a sun synchronous orbit? It should be in sync with sun. That is, whenever satellite is crossing the equator, solar time should be same. What is meant by this? Let's say when the satellite was crossing the equator for the first time, और उस टाइम सन वॉज ओवरहेड, सोलर टाइम वॉज 12 नून, 12 दोपहर में 12 बजे सन इज ओवरहेड. If solar time was 12 noon, 90 minutes later when it will be crossing from some other point, there also solar time should be 12 noon. 90 minutes later when it's crossing again from a point on the equator, solar time should again be 12 noon. That is, sun should be overhead. Right? अब देखो, it is in sync with sun does not mean that sun always have to be overhead. I'm saying it should be in sync with sun all the time. अगर sun पहली बार overhead था तो second time it should be overhead, third time it should be overhead. अगर पहली बार sun डूब रहा था, let's say my orbit is this. In this scenario, what would happen when it is crossing the equator? शाम हो रही होगी, सूरज डूब रहा है इस पॉइंट ऑफ व्यू, इस पार्ट ऑफ द अर्थ के लिए. नाउ ये थोड़ा सा 90 मिनट्स में रोटेट हो जाएगा. इट वुड अगेन बी क्रॉसिंग द इक्वेटर एट अ पॉइंट. उस टाइम भी सूरज डूब रहा होगा. डिड वी अंडरस्टैंड दिस? सो इट इज इन सिंक विथ सन. इट इज इन सिंक विथ सन. सन synchronous polar orbit. This orbit is in sync with sun. Now you would say, sir, every orbit would be in sync with sun. No. To understand this, कौन आप मेरी हेल्प करोगे? आ जाओ, आप सन बन जाओ. ये पेन नहीं, तुम सामने आओ. ये लड़का है सन, एकदम सामने रहो, सामने. अच्छा हाँ, ऐसे रहो. ये सन है, ठीक है. ये मेरा सैटेलाइट है. व्हाट्स योर नेम? हर्ष. हर्ष सन है, ये अर्थ है और ये सैटेलाइट है. लेट्स से वी आर टॉकिंग अबाउट, तुम सामने ही रहो भाई, ऐसे सन नहीं हिलता, अर्थ रिवॉल्व्स. The satellite is revolving like this. Are we all able to understand this? तो 90 minutes later it would again come. अर्थ ये वहीं पे है, हम वहीं पे, राइट. यू मे थिंक कि हाँ ये हर बार सिंक में रहेगा, बट नाउ थिंक ऑफ दिस. इन 90 days व्हाट वुड हैपन? अर्थ वुड हैव मूव्ड हियर. अर्थ रिवॉल्व भी तो हो रहा है ना. वहां व्हेन वी वर हियर, सदर्न हेमिस्फीयर में सन डायरेक्टली पड़ रहा था, नॉर्दर्न हेमिस्फीयर में विंटर था. व्हेन वी रीच हियर, मार्च आ गया है, सन इज डायरेक्टली ऑन द इक्वेटर, है ना. दिस इंक्लिनेशन ऑफ अर्थ 66 डिग्री इंक्लिनेशन ऑफ अर्थ, 66 डिग्री इंक्लिनेशन ऑफ अर्थ, राइट. डू यू अंडरस्टैंड दिस? बट इफ द सैटेलाइट कीप्स रिवॉल्विंग लाइक दिस, कीप्स रिवॉल्विंग, इज इट स्टिल इन सिंक? नो. यहां पे तो वो दोपहर में क्रॉस कर रहा था, but when the earth reaches here, it is crossing in the evening. In fact, the very next day when earth has slightly moved, it would not be in sync. इसका sync थोड़ा सा तो पहले दिन ही चला गया. Are we all able to understand this? हर्ष, आपको समझ में आया? पक्का? देख लो, तुम थोड़ा और इधर हो, तुम दिख नहीं रहे कैमरे में, सूरज ही नहीं दिख रहा. It will be in sync with sun throughout the day, not on the other. On the other side, it is in sync in some other way. हमेशा darkness में रहेगा, right? Did we understand? तो यहाँ पे आ गया तो it doesn't remain in sync, but we want it to remain in sync. So an orbit which is sun synchronous polar orbit will also precess. Precess मतलब अभी ये ऐसे ऐसे घूम रहा था, ये इसका ऑर्बिट भी ऐसे मूव होगा. Now it will revolve like. By the time it comes here, it should be revolving like this. बात समझ में आई? Let me again explain you without Earth. Here, orbit was like this. By the time it reaches here, orbit should be like this. So, this was the motion here, है ना. इसे रोटेट तो करते ही रहना इस तरह से, बट it also has to change its orbit to this direction. It cannot keep revolving like this, else it would not be in sync. So a sun synchronous orbit, a satellite in sun synchronous orbit, उस ऑर्बिट को भी इन 365 days 360 डिग्री रोटेट करना. That orbit will have to rotate by 90 degree, by 90 degree, by 90 degree, and by 90 degree, 360 degree in 365 days in order to remain in sun synchronous, in order to remain sun synchronous. Did we all understand this? Did we all understand? The orbit will also have to change by almost 1 degree every day. 365 days में 360 degrees, roughly by 1 degree every day. This is sun synchronous polar orbit. This is sun synchronous polar orbit. Now this change in the orbit, this आपने लट्टू को देखा है? लट्टू, do you know लट्टू? लट्टू, what is लट्टू called in English? टॉप. टॉप तो टी शर्ट को भी बोलते हैं ना, वो भी टॉप है. इंग्लिश लैंग्वेज ही खराब. टॉप, टॉप. Now you would, if you have seen lattu, lattu rotates, but at the same time it sometimes moves like this, right? While it is rotating, उसका ये वाला प्रिसिशन वाला मोशन भी होता है. सेम इज द केस विद दिस ऑर्बिट. सैटेलाइट इस ऑर्बिट में रोटेट तो कर ही रहा है एवरी 90 मिनट्स, बट इन 365 डेज इसका ये ऑर्बिट विल शुड बिकम दिस, शुड बिकम दिस, शुड बिकम दिस, शुड बिकम दिस, एंड शुड बिकम. Did we understand sun synchronous polar orbit now? Now your question, a question comes. अभी हम बताएंगे sun synchronous polar orbit कैसे possible है. But what is the need of sun synchronous polar orbit? Why do we want that our Earth observation satellite should go in sun synchronous polar orbit? One core reason is, देखो, we are taking image of Earth at the same light every time. What is the advantage? So if we had taken images, लेट्स से हम ब्राजील का इमेज ले रहे हैं, ब्राजीलियन रेन फॉरेस्ट का, हमने उसका जब भी इमेज लिया, वी टुक इमेज एट 12 noon. बट इफ दैट वाज नॉट द केस, सम इमेज वी वर टेकिंग एट 12 noon, some image we were taking at 6 p.m. in the evening. At that time, in long run, when we would have compared images, there would be somewhere darkness, there would be somewhere brightness, right? When we are taking images at the same light, we would be able to do long-term comparison to understand how much of greenery has actually been lost in Brazil and how much of it has increased, something like that. Did we understand this? So we talked about low Earth orbit. In low Earth orbit, we first talked about, we talked about circular orbit. In circular orbit, we talked about low Earth orbit. We saw कि low Earth orbit कहाँ use होता है, which satellites would be in low Earth orbit. At the same time, we also understood a special type of low Earth orbit called sun synchronous polar orbit. Now this precession orbit precesses by 360 degree in 365 days. This precession is not possible around spherical planet. जो planet exactly spherical होते हैं ना, वहां पे precession होना मुश्किल होता है. This precession is possible around what are called oblate planets. Oblate planets are those planets which are suffering from obesity. That is, उनके पेट के पास, उनके इक्वेटर के पास ज्यादा मास है और ऊपर कम है. Those planets are oblate planet. जैसे Earth has, is Earth spherical? No. Earth is geoid. So Earth is also an oblate planet. Abhi we will not get into how oblate planet is needed for making this precision happen, but understand, मतलब इसे याद रख लो कि precision would only happen around oblate planet, right? तो यहाँ पे हमने sun synchronous polar orbit पढ़ाया है. यही बता रहे हैं कि when the satellite is crossing the equator, if it was 12 noon, next time when it will be crossing the equator, it will be crossing at some other point, but it should be 12 noon here, 12 noon, and by 12 noon we mean solar 12 noon, not उन्होंने उस देश में उन्होंने क्या टाइम रखा हुआ है. Like what we may have, entire India में हम we use the same time zone. So when the satellite is crossing northeast India, it may be 12 noon, but when it is crossing again Bhopal this time, it cannot be 12 noon as per India's time because India में time बदल गया, but as per solar time, सूरज उस टाइम वहां ओवरहेड था, सूरज इस टाइम यहाँ ओवरहेड. So we are talking about solar time. Did we understand this? So sun synchronous polar orbit we have understood. Generally a typical sun synchronous polar orbit is at a height of 600 to 800 kilometer altitude. Is this a low earth orbit? हाँ. इसका जो टाइम रेंज होता है वो 96 to 100 मिनट्स होता है. तो 90 to 100 मिनट्स में it can complete one revolution. It is possible only around oblate planet like Earth and Mars. Venus is too spherical to allow sun synchronous orbit to happen. What is the significance of sun synchronous polar orbit? Long term comparison of images would be possible because every time image is being taken at the same light. Kinds of satellite which are put in sun synchronous polar orbit, generally satellite which want constant sunlight. For example, Earth imaging satellites, spy or weather satellites may be put here. India का Cartosat series of satellites, Cartosat 2 series of satellites में we have launched a number of satellites where which is helping us create maps. Carto is map, है ना? Those are sun synchronous polar orbit में launched satellites. Did you understand what is low Earth orbit and then sun synchronous polar orbit, a special type of low Earth orbit satellite? Okay. Online, there is one doubt by Swarna Mukhi who is asking, will it be in sync with sun throughout the day? So yes, it will be in sync with sun throughout the day. That we understand. Next time जब वो आएगा, next time जब वो आएगा, next time जब आएगा, every time it is in sync with sun, है ना? तो इसके लिए दिन बदल ही नहीं रहा. Whenever it's crossing the equator, it is 12 noon. Whenever it's crossing on the other side, it is some fixed time, right? Now, medium Earth orbit. What is medium Earth orbit? From 2000 kilometers to 35786 kilometer. From the height of 2000 kilometer to the height of 35786 kilometer is medium Earth orbit. Do we all understand this? What at a height of 2000 kilometer? What was the orbital period of a circular orbit? 2 hours. At a height of 35786 kilometer, what is the orbital period? 24 hours. इसके बीच में what will be the time period? 2 hours to 24 hours. 2 hours to 24 hours. So 2000 kilometer to 35786 kilometer, time that would orbital period that it will have will be 2 hours to 24 hours. इसमें एक special height है, height of 20,200 kilometer. At this height, it exactly takes 12 hours to complete one revolution. At this height, it exactly takes 12 hours to complete one revolution. समझ में आ रहा है? 2 hours से 24 hours जा रहे हैं तो कहीं किसी हाइट पे तो 12 hours वाला टाइम भी आएगा, किसी हाइट पे 11 hours वाला भी टाइम आएगा, किसी हाइट पे 13 hours वाला भी टाइम आएगा. तो दिस स्पेशल हाइट इज वेरी इंपॉर्टेंट बिकॉज जनरली जो वो होते हैं ना नेविगेशन सैटेलाइट, जैसे जीपीएस. डू वी ऑल यूज जीपीएस? टुडे वी विल अंडरस्टैंड हाउ जीपीएस फंक्शन. डू वी ऑल यूज माइक्रोवेव्स? माइक्रोवेव ओवन यूज करते हो? हम इस बुकलेट में ये भी समझेंगे माइक्रोवेव ओवन कैसे काम करते हैं व्हेन वी गो टू इलेक्ट्रोमैग्नेटिक वेव्स. ओके, तो जीपीएस के जो सैटेलाइट्स हैं दे आर ऑल लॉन्च्ड इन मीडियम अर्थ ऑर्बिट एट अ हाइट ऑफ 20,200 किलोमीटर. तो जो सैटेलाइट नेविगेशन वाले सैटेलाइट्स होते हैं, सैटनैव सैटेलाइट्स, satellites which are contributing in navigation, they are generally, please note I'm again using the word generally, जैसे इंडिया का जो नाविक है IRNSS, they are put in geosynchronous orbit, they are not put in at this height. चाइना का जो बाइडू है, some of them are put in medium earth orbit but some of them are in geosynchronous orbit. It may vary, it may differ, but they are generally put here. GPS satellite fly in medium earth orbit at an altitude of 20,200 kilometers. Galileo, the satellite navigation system of Europe, is also located at a height of 20,000 in medium earth orbit. So generally in medium earth orbit, what do we put? Navigation satellite. Okay, let's now go to geosynchronous orbit. Geosynchronous. This is the Earth, huh? And the satellite which is in, let's say, this circular orbit ही है, हाइट उसका यूनिफॉर्म है 35,786 किलोमीटर. अब 35,786 किलोमीटर पे व्हाट डिड वी से, इट विल टेक 24 आवर्स टू कंप्लीट वन रेवोल्यूशन. इट विल टेक 24 आवर्स टू कंप्लीट वन रेवोल्यूशन. तो फिर से मुझे अर्थ मान लो, ऑब्लेट वाला. फाइन. दिस इज अ सैटेलाइट विच इज इन सर्कुलर ऑर्बिट. सर्कुलर है बट इंक्लाइंड है, एग्जैक्टली इक्वेटर के ऊपर नहीं है, इंक्लाइंड है ना. सर्कल, ऐसा भी सर्कल हो सकता है ना. इट्स इन सर्कुलर ऑर्बिट. नाउ दिस सैटेलाइट इज टेकिंग 24 आवर्स टू कंप्लीट वन रेवोल्यूशन. अब सपोज मेरा बेल्ट इज इक्वेटर, बेल्ट के ऊपर इंडिया है, दिल्ली यहाँ पे है मान लो, दिल के पास. किधर है दिल्ली? इधर है, इधर होगा ना? नहीं होगा तो उधर पर धड़क नहीं रहा है. तुम सबको पता है ना कहाँ होता है, मेरा तो इधर है. चलिए, नहीं लेफ्ट में ही है, पता नहीं मिल नहीं रहा. टूट गया, चुरा ले गया कोई. चलिए वापस आते हैं. इंडिया यहाँ पे है ना. आप यहाँ हो और एक जियोसिंक्रोनस ऑर्बिट है. नाउ सी, इट इज टेकिंग 24 आवर्स टू कंप्लीट वन रेवोल्यूशन. तो इन 24 आवर्स, बाय द टाइम सपोज यू आर इन दिल्ली लोकेटेड हेयर, 24 आवर्स में जब आप यहाँ होगे, सैटेलाइट वुड ऑल्सो बी बैक हेयर, है ना. 24 आवर्स बाद वो यहीं पे है. तो अर्थ के सिंक में ऐसे है कि एट आफ्टर 24 आवर्स इट वुड बी बैक एट द सेम पॉइंट, बिकॉज सर्कल में ऑर्बिट तो ऐसे ही कर रहा है. बट कंसिडर दिस, आफ्टर 6 आवर्स व्हाट वुड हैव हैपेंड. आफ्टर 6 आवर्स वो यहाँ पे होगा, है ना. देखो वो ऊपर चला जाएगा. और लेट मी सिंप्लीफाई इट फर्दर. बड़ा बना देते हैं. ओके, इंडिया यहाँ पे है. तो लेट्स से कुछ टाइम पहले, नाउ sometimes back, or for now, let's say you are here and you see satellite here right. After 24 hours you will be back here, satellite would be here. But after 3 hours क्या होगा? After 3 hours you would be here, earth would have rotated, satellite would be here. So satellite is not stationary for you, it's moving up. Then as it starts coming down on the other side, for you it will be coming down, then it will go below you, then it will come back again. Satellite is not stationary for you, but after 24 hours it would be back at the same point. Geosynchronous. Did we understand this? Did we understand this pakka? तो देखो, for a satellite to be geosynchronous it has to satisfy a few conditions. अच्छा, यहाँ पे हम geosynchronous बता रहे हैं कि this is geosynchronous. Now for a satellite to be in geosynchronous orbit, one, it should be in circular orbit at a height of 35,786 kilometers. It cannot be elliptical, or it cannot be, it has to be circular at a height of 35,786 kilometers. Its direction of revolution should be same as the direction of revolution of rotation of earth. अगर अर्थ ऐसे रोटेट कर रहा है और ये ऐसे रोटेट कर रहा है तो सेम पॉइंट पे 12 घंटे बाद भी आ जाएगा, राइट. तो if earth is rotating like this, the satellite should also be going like this. For a satellite to be in what? Geosynchronous orbit. Circular orbit, सर्कुलर होना चाहिए पहला पॉइंट. दूसरा 35786 किलोमीटर के हाइट पे होना चाहिए. एंड तीसरा, इट शुड बी रिवॉल्विंग इन द सेम डायरेक्शन एज द अर्थ इज in which the earth is rotating. फाइन, ये सबको समझ में आया है पक्का? जियोसिंक्रोनस ऑर्बिट. नाउ अभी जियोसिंक्रोनस में ना एक स्पेशल टाइप होता है, जियोस्टेशनरी. जियोस्टेशनरी इज अ टाइप ऑफ जियोसिंक्रोनस, बट इट्स अ स्पेशल टाइप. अभी हम क्या बोल रहे थे? दिस इज आवर ऑर्बिट, बट इफ वी से दैट आवर ऑर्बिट इज नॉट ऐसे इंक्लाइंड, दिस इंक्लिनेशन को आप जीरो कर दो. दिस ऑर्बिट इज एग्जैक्टली अबव इक्वेटर. In that scenario, what happens when it is exactly above equator? I am taking 24 hours, it is also taking 24 hours. नाउ थिंक ऑफ फ्रॉम सम पर्सन्स पर्सपेक्टिव, लेट से कोई पर्सन है जो साइबेरिया में है, साइबेरिया ऊपर यहाँ पे रशिया में, या नॉर्थ पोल पे, चलो नॉर्थ पोल पे नहीं जाते, रशिया में जाते हैं। व्हेन दैट रशियन पर्सन इज लुकिंग एट दी सैटेलाइट, वो हमेशा ऐसे ही देख रहा है, आफ्टर 6 आवर्स भी यहीं पे देख रहा है, आफ्टर 6 आवर्स अगेन यहीं पे देख रहा है, आफ्टर 6 आवर्स भी यहीं पे देख रहा है। एट एवरी मोमेंट द सैटेलाइट इज स्टेशनरी, एट एवरी मोमेंट द सैटेलाइट इज स्टेशनरी। ये समझ में आ रही है बात सबको? एट एवरी मोमेंट द सैटेलाइट इज स्टेशनरी व्हाइल द सैटेलाइट इज रिवॉल्विंग, वो बहुत तेज रिवॉल्व कर रहा है, फास्टर देन एनी पॉइंट ऑन अर्थ, क्योंकि उसका रेडियस बहुत ज्यादा है अर्थ से, बट फ्रॉम एनी पॉइंट ऑन अर्थ इट वुड अपीयर स्टेशनरी। इसे ऐसे समझो। लेट्स अब रियल वर्ल्ड में जाते हैं। लेट्स थिंक ऑफ, हम अर्थ पे बैठे हैं, वी आर इन द नॉर्दर्न हेमिस्फीयर, इस तरफ साउथ है, हमारे हमारे इस तरफ साउथ है, इक्वेटर वहां उस तरफ होगा, इक्वेटर के ऊपर सोचो कोई सैटेलाइट है, इक्वेटर के ऊपर ऊपर कोई सैटेलाइट है, वी हैव लॉन्च्ड द सैटेलाइट देयर, फॉर अस इट विल ऑलवेज रिमेन देयर, इट विल नॉट मूव, बिकॉज सैटेलाइट थोड़ा आगे बढ़ा होगा, बट अर्थ वुड हैव आल्सो rotated, so for us it would always be there. Let's say satellite was launched above Africa, डेमोक्रेटिक रिपब्लिक ऑफ कॉन्गो के ऊपर लॉन्च हुआ है, तो हमें वहां पे दिखेगा सैटेलाइट, बट देन इट वुड ऑलवेज बी देयर फॉर us, इट वुड ऑलवेज बी स्टेशनरी, we'll be able to point, वो रहा, it won't change, no matter what, whether it's day or night or what, it won't change. Was geosynchronous changing its position? Yes, it was moving up, it was coming down, it was geosynchronous was changing, but geostationary is stationary, right? तो geostationary is a special type of geosynchronous. Geosynchronous देखोगे ना, वो आपको roughly it makes a shape of 8 for you, it makes a shape of 8, geosynchronous, it will go up, it will come down, go down, come up, and so on. Geosynchronous will roughly make a shape of 8 when you look at it. क्या geosynchronous हमेशा आपको विजिबल रह सकता है? रह सकता है, अगर वो आपके साइड ही लॉन्च हुआ है, it will go up and down, but you'll always be able to see it, up, down, down, up, you'll always be able to see it. People on the other side of planet may not be able to see it, तभी तो वो पूरा 8 of 8 का शेप आपके लिए बना रहा है। जियोस्टेशनरी में कोई अप डाउन नहीं होगा, इट विल बी स्टेशनरी राइट अबव द इक्वेटर। तो जियोस्टेशनरी में क्या है, बिकॉज इट्स राइट अबव द इक्वेटर, इट विल बी एट दैट पॉइंट, नो शेप ऑफ इट। डिड यू अंडरस्टैंड जियोस्टेशनरी सैटेलाइट्स? Mohit is asking why is it called sun synchronous but not earth synchronous? Why it is not in sync with earth ना, sun synchronous की बात कर रहा है, it is in sync with sun, whereas this geostationary is in sync with earth. Geostationary और geosynchronous is in sync with earth. After every 24 hour आप अर्थ पे यहाँ पॉइंट करोगे वहीं होगा. Is geostationary also geosynchronous? Yes, it is at a height of 35786 kilometer. It is circular, and after 24 hours, is it back at the same point? Yes, it is at the same point always. So it is back at the same point after 24 hours. So geostationary is also a type of geosynchronous. Okay, so let's go to geostationary, a special type of geosynchronous. यहाँ पे क्या होगा, जियोसिंक्रोनस के सारे रिक्वायरमेंट फुलफिल होने चाहिए. व्हाट वर द रिक्वायरमेंट ऑफ जियोसिंक्रोनस? सर्कुलर ऑर्बिट एट अ हाइट ऑफ 35786 किलोमीटर, एंड path of rotation should have been same as the path of revolution of, path of revolution should be same, orbit का जो revolution का path है it should be same as the path of revolution of or rotation of earth, है ना. यहाँ पे जियोसिंक्रोनस के सारे रिक्वायरमेंट प्लस द इक्वेटोरियल प्लेन ऑफ अर्थ मस्ट बी कोप्लेनर विद द ऑर्बिटल प्लेन ऑफ द सैटेलाइट. दैट इज इक्वेटर का जो प्लेन है सैटेलाइट का भी वही प्लेन रहना चाहिए. इट शुड बी राइट अबव द सैटेलाइट. तो जियोसिंक्रोनस ऐसा होगा, राइट. दिस इज एन और सॉरी गड़बड़ कर दिया मैंने, दिस इज एन ऑर्बिट, जियोसिंक्रोनस ऑर्बिट है ना, इसका इक्वेटर से कोई एंगल हो सकता है, इट कैन बी 0 डिग्री, 1 डिग्री, 2 डिग्री, 3 डिग्री, 40 डिग्री, 50 डिग्री, कुछ भी हो सकता है, it can be 0 degree also. So when it is 0, then it is geostationary. When it is 0 degree, then it is geostationary. Got it? ये समझ में आया? Yes. हाँ, it might it actually देखो, yes देखो फिर से समझो, it may never be visible to you. ऐसे समझिए, let's go back here, let's go back to this image. Suppose a satellite was launched, that satellite is here. Now think of people who are on the other side of the planet. उनको तो कभी नहीं दिख रहा है सैटेलाइट. Now आपके लिए अगर ये आपको दिखा है, in sometimes it would have moved somewhat horizontally, but you would have also moved. So it will be making a shape of 8 for you. It would move up, then it will start coming down. 8 में it is moving up. उसका projection जब हम अर्थ पे ले रहे हैं, it is moving up, it's coming down, it is coming down here. ये इक्वेटर से और भी नीचे जाएगा, इक्वेटर से और भी नीचे गया इस 8 में, and then it comes up. So if it's visible to you, it would be visible to you. If it's not visible to you, it will not be visible to you. Why not 0? अब बेटा एक्चुअली ना उसके लिए थोड़ा सा मैथमेटिक्स का प्रोजेक्शन वाला चीज समझाना पड़ेगा, उसमें नहीं जाते हैं. ओके, अंडरस्टैंड कि इट शेप्स इट मेक्स इट कि हाउ वो फिर मेरे को वो क्या बोलते हैं मशीन डिजाइन एंड ईडीएमडी वाला लेक्चर कराना पड़ेगा, इंजीनियरिंग वाला. ओके, अभी समझ में आया आपको? ओके, जियो स्टेशनरी. तो जियो स्टेशनरी मतलब व्हाट? रिमेंबर दैट मैंने बोला वहां पे तो हमेशा वहां पे. जियो स्टेशनरी वाज दिस. So if I have to launch a communication satellite, it can be launched in geostationary orbit. I can point my antenna in that direction, and फिर आपको antenna move नहीं करना पड़ेगा. It will be in that direction. That's it. Communication satellites generally are put in geostationary so that you do not have to move your antenna. Earth observation satellites were in low Earth orbit, क्योंकि अर्थ के पास में है. Navigation satellites generally in medium Earth orbit. Generally, we'll understand how navigation happens. By that, you'll understand कि कैसे it can be in other orbits also. And communication satellites in geostationary orbit. Now, please note something that communication satellites be in geosynchronous orbit? Yes, but आपको अपना एंटीना फिर ऐसे 8 के शेप में मूव करते रहना पड़ेगा to always point it in that direction. Say it would go like this. Because satellite is going like this, right? In case of low Earth orbit, can you put communication satellites there? Yes, you can put communication satellite there, but there's a problem. 45 minutes later, communication satellite would be on the other side of Earth. आप तो उससे communicate कर ही नहीं पाओगे, line of sight में नहीं है. तो when you are putting communication satellites in low Earth orbit, आपको उस orbit में बहुत सारे satellites launch करने पड़ेंगे, so that when the one satellite is on the other side, there are some more satellites here using which you are communicating. No, Starlink is internet wala project. We'll come to that. Normal communication, when it is satellite communication, which our military may be using, they are using various low Earth orbit satellites. But by various, what I mean is, think of this: Earth and a low Earth orbit satellite. So if you are putting in this orbit only one satellite, what would happen? This one satellite would be on the other side of the planet. This one satellite would be on the other side of planet after 45 minutes. आपको तो दिखेगा नहीं, आप बात कैसे करोगे? So you will put another satellite here, another here, another here, so that एक चला गया तो दूसरा आ गया, तू नहीं तो कोई और सही, बात होनी चाहिए, right? Got it? So to ensure कि communication is permanent, else you'll have to wait for 45 minutes when the satellite comes back into play. Okay, the three types और इसके beyond जो orbit है, that is high earth orbit. High earth orbit is at a height beyond 35786 किलोमीटर, उसका orbital period 24 hours से भी ज्यादा होता है. तो that doesn't serve a lot of purpose for us. किसी का orbital period 25 hours हो रहा है, तो like for that satellite to come back to you, there would be a lot of gap. Are you understanding? है ना, वो स्लो चल रहा होगा, पीछे हो जाएगा, पीछे हो जाएगा, पीछे हो जाएगा. Then it won't serve any purpose to you. Very few satellites go in high earth orbit when it comes to circular orbit scenario. Okay, now what are the advantages of geosynchronous orbit? Please note, when I am using the word geosynchronous, geostationary is included in it. Right? Geostationary is a subtype of geosynchronous. But when I am using the word geostationary, then all geosynchronous is not included in it. Geostationary, when I am using the word geostationary, all geosynchronous would not be included. Not all geosynchronous satellites would be geostationary, but all geostationary would be geosynchronous. Right? So geosystems have significantly greater available bandwidth than the low Earth orbit or medium Earth orbit. So these satellites generally have much higher bandwidth. We'll understand this. मुझे थोड़ा सा electromagnetic waves में आने दो. Then one satellite can cover much larger area of Earth. ऐसे सोचो कि if you are very close to Earth, if let's say this is Earth has a radius of 6400 kilometers, और आप Earth से let's say only 500 kilometers दूर हो, low Earth orbit में satellite इतनी दूर होगा, तो its line of sight would be able to cover perhaps this area. It won't be able to cover a large area. But when you are 36,000 kilometers away, ये इस रेडियस से 6 गुना ज्यादा दूर हो, will you be able to cover a large section of Earth? Will you be able to cover a large section of Earth? So one geosynchronous satellite can cover almost 1/3 of the Earth. तो अगर उस geosynchronous orbit में you launch 3 satellites at 120 degree gap, you can cover the entire Earth. So that is other advantage. Covers 1/3 of the Earth's surface. One satellite can cover 1/3 of the Earth's surface. Less expense on tracking activities. Why less expense on tracking activities? You know, अगर geosynchronous भी है तो this is the path. Geostationary है तो that's it. Less expense on tracking activities. And finally, higher lifespan of satellites. Why would satellites have higher lifespan? Geostationary या geosynchronous में satellites के higher lifespan क्यों होंगे? Because one is 500 kilometers के height पे ना, there is some kind of like Earth का gravity higher है, plus atmosphere का जो भी remaining components हल्का फुल्का सा रहेगा वो रहेगा. At a height of 36,000 kilometers, chances of colliding with other satellites, chances of getting affected by anything else, everything is negligible. There's no problem at all. Fine? Did we get it? Okay. हाँ, solar flares है तो he is right कि sir there would be more solar flares, but we ensure we provide our satellites with some solar flare protection that is taken care of. Okay, but there are some limitations. एक limitation ये होता है कि communication में there would be delay because it is very far away, 36,000 kilometers when compared to 500 kilometers. Then satellite is costlier to install. Making satellite reach there is expensive. Do we understand why making satellite reach there would be expensive? Because आपके रॉकेट को सैटेलाइट उतनी दूर लेके जाना पड़ेगा. Then geostationary satellite will never be able to cover polar region. Why? ऐसे समझो, अर्थ इज जियोइड, ऊपर थोड़ा सा प्लेन है और यहाँ पे ज्यादा मास है. नाउ इफ द सैटेलाइट इज हियर ओनली, यू कैन अंडरस्टैंड कि जो टॉप का एरिया है, पोल का एरिया, इट विल नेवर बी इन लाइन ऑफ साइट. So geostationary satellites are not able to cover polar region. That is another limitation. when you launch a communication satellite, a series of communication satellite in geostationary orbit, you are not able to cover the polar region. सबको समझ में आया? Is this properly understood? Okay. Now, highly elliptical पे आ जाते हैं. Highly elliptical orbit, you see, आपने सैटेलाइट लॉन्च किया at a speed more than under root gm by r, it went away, it eventually slowed down, turned back, speed फिर से बढ़ा, फिर कम हुआ, बढ़ा. There would be a point which is near to earth, that is called perigee. I remember it like this, perigee pass में, apogee away, apogee which is furthest, further away. So it follows curve of an ellipse, moves much faster when it is near earth and slower when it is away from earth. There are two focal points, and one of these is called the geocenter of the earth. Apogee points where the satellite is furthest from earth, perigee point where the satellite is nearest to the earth. How permanent coverage can be achieved in this scenario? Sometimes communication satellites sometimes can be launched in highly elliptical orbit also, और वहाँ से भी permanent coverage हो जाता है. और sometimes earth observation satellite can also be launched in highly elliptical orbit and वहाँ पे भी permanent coverage हो सकता है. कैसे? What they do is they do something like this. ये अर्थ है, this kind of elliptical orbit. What happens is, अब देखो, this is not correct drawing of elliptical orbit, mathematics की class नहीं है, so we are not concerned about that. Now think of this satellite, when it is on this side, it will be moving slower, slowest here, थोड़ा फास्ट होना शुरू होगा, ये वाला पार्ट फटाफट खत्म कर देगा, because here it is very fast, here it is slow. So this side, on this side, it remains on this side for a much larger time period when compared to this side. So on this side it can kind of provide permanent coverage, kind of, not exactly permanent but kind of, but not very relevant for us. थोड़ा सा आइडिया रहना चाहिए. Applications, it may provide high latitude, provide coverage at any point on the globe. It may provide high latitude and polar coverage. Elliptical orbit, high latitude पे polar coverage can be given. Countries such as Russia, which needs coverage over polar and near polar areas, make significant use of highly elliptical satellite. हम topics में located हैं, तो for us highly elliptical satellites do not serve a lot of purpose. We generally do not launch satellites in highly elliptical orbit. आप देखोगे हमारे satellites या तो जियोसिंक्रोनस जियोस्टेशनरी में जा रहे होंगे या लो अर्थ ऑर्बिट, उसमें भी SSPO में जा रहे होंगे, SSPO और लो अर्थ ऑर्बिट. फाइन. नाउ एक ऑर्बिट्स में लास्ट चीज बचा है, ट्रांसफर ऑर्बिट, before we jump on to rocket. Let's talk about transfer orbits. What are transfer orbits? सबको नींद आ रही है? नहीं, जगह हो ना. थिंक ऑफ अर्थ, एक सैटेलाइट, एक ऑर्बिट इन लो अर्थ ऑर्बिट, एक ये जियो स्टेशनरी ऑर्बिट. लो अर्थ ऑर्बिट, जियो स्टेशनरी ऑर्बिट. नाउ वी वांट टू लॉन्च अ सैटेलाइट. एक रॉकेट will take the satellite to this orbit. A rocket can take the satellite to this orbit. Where would we need a much powerful rocket? छोटे वाले में, है ना? So what we generally do is, even if we want to launch a satellite here in geostationary orbit, हम क्या करेंगे? We take the satellite and we launch it in low earth orbit only. छोटा वाला circular orbit में we launch it. ऐसे हम इसे launch करेंगे. Let's say this is अर्थ, यहाँ से हमने लॉन्च किया एंड हियर इट गॉट प्लेस्ड इन द लो अर्थ ऑर्बिट. लो अर्थ ऑर्बिट में है. व्हाइल लॉन्चिंग वी विल गिव इट अ स्पीड विच इज मच हायर देन अंडर रूट GM by this r. We'll give it a speed so that it goes in a elliptical orbit. Now when it goes in an elliptical orbit, it will sometimes reach this height of 35786 kilometer. वहां पे now the satellite is alone, rocket is not there, but we give satellite some fuel, some engine, and we control it. When it reaches at a height of 35786 kilometer, its engine starts, extra force is applied, and it changes its direction to come in this circular orbit. So our rocket only had to carry the satellite to low Earth orbit. In low Earth orbit, it launched it in this elliptical orbit. This elliptical orbit is called transfer orbit. It is used to, this elliptical orbit was used to transfer satellites from a small circular orbit to a large circular orbit. This is, you can see this image. हमने सैटेलाइट को लॉन्च किया छोटे वाले सर्कुलर ऑर्बिट में. From here, this is what? Elliptical orbit, which is the transfer orbit, which is used to launch satellite from a rocket to low Earth orbit, and from low Earth orbit it is transferred to high Earth orbit or large radius वाला orbit. ये बहुत इंपॉर्टेंट है, समझ लो. इसीलिए you because अभी when we'll talk about चंद्रयान, when we'll talk about मंगलयान, उन सब में this concept would be used. All those topics would use this basic concept. Got it? पूरा सबको समझ में आ रहा है? ओके. नाउ ये अभी तक जो हमने पढ़ा उस सबका समरी है. विकिपीडिया से एक इमेज मिला था मुझे. नाउ अंडरस्टैंड दिस. फर्स्ट लेट अस लुक एट हाइट वाला आइडिया. Here height is varying. You can see this height, 30,000 kilometers, 36,000 kilometers, 20,000 kilometers, 10,000 kilometers. तो देखो 2000 किलोमीटर से 2000 किलोमीटर से 36,000 किलोमीटर तक क्या है? मीडियम अर्थ ऑर्बिट. 2000 बहुत पास में होगा यहीं की. तो अब देखो सारी जो चीजें हैं, इंटरनेशनल स्पेस स्टेशन, ये सब कहाँ पे हैं? लो अर्थ ऑर्बिट में. 20,000 किलोमीटर के आसपास, 20,200 किलोमीटर पे 12 आवर्स टाइम लगता था. रिमेंबर, यहाँ पे व्हाट डू वी लॉन्च? वी जनरली लॉन्च इन मीडियम अर्थ ऑर्बिट नेविगेशन, सैटेलाइट नेविगेशन. यू सी एट दिस हाइट व्हाट डू वी हैव? जीपीएस, गैलीलियो, GLONASS, Baidu. These are all satellite navigation systems. We will study about each one of them. अभी आते हैं थोड़ी देर में. Then geostationary orbit, सबसे हाइट वाला 36,000 किलोमीटर हाइट वाला geostationary orbit. If you do not want to consider height, you want to consider radius, तो 36,000 किलोमीटर के ऊपर 6,400 किलोमीटर और ऐड कर दो, you will get the radius. Here they are talking about radius. Look at the speed of the satellite, time that satellite would take. You would see that low Earth orbit में बहुत कम टाइम लग रहा है. As you move up 2 hours से 5 hours, 10 hours, 12 hours, 24 hours. Now a very interesting aspect. किस स्पीड पे सैटेलाइट मूव कर रहा है? When it is closer to Earth, it is moving at very high speed. See 25,000 km per hour. As it is moving away from Earth, 20,000, 15,000 km per hour, 11,000 km per hour. But even in geostationary orbit, it is moving at 11,000 km per hour. एक सैटेलाइट किस स्पीड पे मूव करता है उसका एक अंडरस्टैंडिंग रहना चाहिए. Did you get this? Now think of your car which is moving at a speed of 200 km per hour. ऐसे लाइफ थ्रेटन सी लगती है आपको? हैं? बीच में एक बड़ा पत्थर आ जाए and you go and collide with that पत्थर at 200 km per hour. Can you understand what will be the condition of your car? I'm not asking your condition. Right? Now, if an object is moving at a speed of 20,000 km per hour or 25,000 km per hour, उसके सामने एक छोटा सा ऑब्जेक्ट भी आ जाए, एक पिन आ जाए छोटा सा, that the impact of that would be so much that it would be destroyed. एक speck of paint का जो छोटा सा टुकड़ा निकल जाता है ना, even that would be moving at a speed of 25,000 km per hour. वो ह्यूमन बींग्स को जब क्रॉस करेगा ना पूरा छेद हो जाएगा. पेंट का एक छोटा सा लेयर. दिस इज दैट हाउ लार्ज स्पीड these satellites are moving. Fine. So this was the basics of orbit. There are some more basic things that we should keep in mind. One is, why are satellites generally launched from east coast? I'll take your doubts. Let me take this. Why are satellites generally launched from east coast? आप देखोगे इंडिया में जो सैटेलाइट लॉन्च प्लेस है वो श्रीहरिकोटा. वेयर इज इट लोकेटेड? तमिलनाडु आंध्रा के बॉर्डर पे यहाँ पे है. जो यूरोप का सैटेलाइट लॉन्च स्टेशन है वो यहाँ पे है, फ्रेंच गुयाना में. यूरोपियन स्पेस एजेंसी यहाँ से सैटेलाइट लॉन्च करती है फ्रेंच गुयाना में, विच इज अगेन ऑन द ईस्ट कोस्ट. यूएस का भी जो मोस्ट पॉपुलर जगह है वो है केप कैनावरल, विच इज लोकेटेड इन फ्लोरिडा. Look at Japan, again on the east coast. So generally satellites are being launched from the east coast. Why is it so? East coast है एक aspect, एक satellites are launched from near the equator. तो पहले let's understand why satellites are launched from near the equator. हम देखो यूएस के पास ये पूरा यूएस इतना बड़ा था, वो कहीं से भी लॉन्च कर सकता था, but it tried to reach near the equator. India, when India launches missile is launched from Sir Abdul Kalam, Dr. APJ Abdul Kalam Island or Wheeler Island near Odisha. But when it comes to launching of satellites, it is launched from श्रीहरिकोटा, आंध्रा और तमिलनाडु के बॉर्डर पे. तो हम भी इक्वेटर के पास जाने की कोशिश कर रहे हैं. Why is it so? It's because think of this, अर्थ रोटेट हो रहा है ना. थिंक ऑफ, इसे ऐसे समझो, जब रोटेट हो रहा है, थिंक ऑफ दिस अपर पॉइंट. 24 घंटे में कितना ट्रैवल कर रहा है? इतना डिस्टेंस. But think of equator. 24 घंटे में how much is it traveling? Much larger distance. So the surface speed of Earth is higher near the equator, is much lower here. Surface speed of Earth is higher near the equator. यहाँ पे कोई पॉइंट है अर्थ के सरफेस पे, its speed is much higher when compared to when it's located here. Now what happens because of this? When we are launching the satellite, let's say जब हम सैटेलाइट को लॉन्च कर रहे हैं, तो इफ द सरफेस स्पीड वुड बी हाई, सैटेलाइट वुड गेट अ टेंजेंशियल स्पीड इनिशियली, एंड दैट इज व्हाई वी ट्राई टू गो एज नियर द इक्वेटर एज पॉसिबल. डिड वी अंडरस्टैंड दिस? व्हाई डू वी ट्राई टू गो एज नियर द इक्वेटर एज पॉसिबल? नाउ व्हाई फ्रॉम द ईस्ट कोस्ट? देखो वी जनरली लॉन्च, हाउ डज अर्थ रोटेट, इन व्हाट डायरेक्शन? वेस्ट टू ईस्ट. अर्थ रोटेट्स फ्रॉम वेस्ट टू ईस्ट, है ना. तो हम ईस्ट कोस्ट से इसलिए लॉन्च करेंगे कि भाई टेंजेंशियल वेलोसिटी का फायदा तभी मिलेगा. if the earth is rotating from west to east and if we are launching the satellite in east to west direction, we don't get advantage of tangential velocity, right? But you may say, sir, फिर उसका कोस्ट से क्या मतलब हुआ? आप यहां से भी लॉन्च कर दो ना. You have to launch it in the east direction. When earth is rotating like this, when this earth is rotating like this, even rather than launching it from Sriharikota, if you were launching it from Mangaluru, वहां से भी तो आप ईस्ट कोस्ट में लॉन्च कर सकते थे. बट इन केस ऑफ फेलियर, अगर आपने इस तरफ से लॉन्च किया, समथिंग रॉन्ग हैपेंस, द सैटेलाइट वुड फॉल ऑन बेंगलुरु, रॉकेट वुड फॉल ऑन बैंगलोर, बैंगलोर से जाके बैंगलोर पे. बट यहाँ पे श्रीहरिकोटा से इफ समथिंग गोज रॉन्ग, इट विल फॉल इन दी ओशन. डिड यू गेट इट? समझ में आ रही है बातें ये? So why from the east coast, this is also understood, but this is not for everyone. Like you will see, Russia has a number of satellite launch places, China has a number of satellite launch places which are at other places. उनको ये advantages नहीं मिल पा रहे, तो नहीं, अब वो इक्वेटर के पास नहीं जा सकते. रशिया का सोचो, सॉरी यूरोप का, यूरोप के लिए बहुत डिफिकल्ट है इक्वेटर के पास जाना. बट फ्रेंच गुयाना, they had this place, French Guiana, they established their system there. Fine. Okay, now let's go to rockets. हाँ, I'll take doubts. मुझे एक सेकंड दे दीजिए. टाइमलाइन देख लेना इंडिया में क्या क्या डेवलपमेंट हुए. Now we'll go to rockets. हाँ, there were some doubts. What were the doubts? Sorry? वो बहुत ऊपर वाली हाइट की, मतलब उसके बियॉन्ड हाई अर्थ ऑर्बिट वाले ऑर्बिट को. Okay, any other doubt? नहीं, you were asking something. Yes. डाउट नहीं है, ऐसे ही पूछ रहे हो? हाँ, देखो ना, अर्थ का रेडियस इज ओनली 6400 किलोमीटर पर किलोमीटर, और उसका रेडियस कितना है 36,000 प्लस 6400, है ना? तो अर्थ का जो रोटेशन स्पीड होगा इट विल बी मच स्मॉलर, अर्थ का रोटेशन स्पीड वुड बी मच स्मॉलर, क्योंकि फिर से ही इज आस्किंग समथिंग, प्लीज समझिए, ही इज सेइंग कि सर इन जियो स्टेशनरी ऑर्बिट द स्पीड ऑफ सैटेलाइट इज 11,000 किलोमीटर पर आवर, तो अर्थ का जो सरफेस स्पीड होगा इट शुड बी मोर देन दैट, नहीं, इट विल बी मच लेसर। सोचो वो बड़े इन जियो स्टेशनरी ऑर्बिट द सैटेलाइट इज इन मच लार्जर ऑर्बिट that it has to cover in 24 hours. Earth radius is much smaller that it has to complete a rotation in 24 hours. But ये तो रोटेशन स्पीड हो गया, अब सोचो अर्थ का रेवोल्यूशन अराउंड सन, इट विल बी मच मच फास्टर। 365 डेज में इट हैज टू कवर अ वेरी लार्ज डिस्टेंस, अ फ्यू मिलियन किलोमीटर्स हैं अर्थ से सन का डिस्टेंस, राइट? 150 मिलियन किलोमीटर समथिंग लाइक दिस, है ना? एक बार हम अर्थ और सन का डिस्टेंस देख लेंगे, बट उतना हमें 365 डेज में कवर करना है, तो अर्थ इज मूविंग वेरी फास्ट, हमें लग नहीं रहा, अर्थ इज मूविंग वेरी फास्ट। नाउ विल कम टू रॉकेट, ओके, आएंगे उनको भी समझाएंगे, विल कम टू सोलर सिस्टम, आई विल एक्सप्लेन यू दैट। सर कैन यू प्लीज रिपीट व्हाई नियर द इक्वेटर? सरफेस, अर्थ का सरफेस का जो मूवमेंट है वो सबसे तेज इक्वेटर के पास होता है, बिकॉज इक्वेटर में सोचो ना, बड़ा सर्कल कवर करना है, पोल के पास छोटा सर्कल कवर करना है इन 24 आवर्स, तो सरफेस स्पीड वुड बी हाईएस्ट एट द इक्वेटर। Okay, let's come to rockets. Before we go into these rockets, like before we talk about PSLV, GSLV and other things, let's understand how rocket functions. At very basic level, how do rockets function? Then understanding PSLV, GSLV and all those things would be very easy. कुछ बेसिक समझ लेते हैं। देखो, पानी पी लेता हूँ यार। Rocket has to take the satellite to a height of 500-600 kilometers. रॉकेट को, सैटेलाइट को वहां लेके जाना है। नाउ थिंक ऑफ दिस अर्थ, यहां से हम रॉकेट लॉन्च करते हैं। What is the gravitational force which will be opposing the rocket, which will be pulling the rocket towards it? Gmm by r square. As this rocket moves away from Earth, r increases, gravitational force reduces. As the rocket moves away from Earth, r keeps on increasing, gravitational force keeps on decreasing. Okay, now how do rockets go away from Earth? What is the force? Have you played with Diwali rockets? है ना, इस साल दिवाली में किस किसने रॉकेट जलाए? एक ही, और किसी ने नहीं? एनसीआर में ना सबको जेल हो जाएगी। बट वहां पे क्या होता है, रॉकेट व्हेन वो पटाखे वाला रॉकेट आप जलाते हो तो वहां से कुछ गैस, धुआं निकलता है, इट प्रोवाइड्स द रॉकेट अ थ्रस्ट विथ विच इट गोज अप, राइट? कभी आपने हैव यू एवर सीन द बर्न डाउन रॉकेट जो जल के नीचे गिरता है? इट इज मच लाइटर बिकॉज उसका सारा वो बारूद वगैरह जल चुका होता है। इट इज मच लाइटर, most of the weight that it had was because of the fuel. Same is the case with our rocket. हम अपन का जो रॉकेट जाएगा ना उसमें 80-90% weight is that of fuel. And where would most of the fuel be used? In the lower part. When this rocket is at lower height, the thrust that it would require to go away from Earth would be much larger. When it is at upper height, the thrust that it would require is much smaller. Why would the thrust be smaller? Because अर्थ का ग्रेविटी कम हो गया, ये और ऊपर जाएगा थ्रस्ट और कम रिक्वायर्ड होगा, ये और ऊपर जाएगा, थ्रस्ट रिक्वायर्ड वुड बी वेरी वेरी लेस। यहाँ पे थ्रस्ट रिक्वायरमेंट और यहाँ पे थ्रस्ट रिक्वायरमेंट में वेरिएशन अप टू 1000 टाइम हो सकता है। वेरिएशन इज दिस मच। टू अंडरस्टैंड द स्केल ऐसे समझो कि here if 1000 people were required to pull something, here only 1 person would be required. इतना वेरिएशन हो सकता है। Imbibe this first कि the thrust that would be required, the force that would be required would be much higher near the earth surface. As you will move away, the force required would be much smaller. As you move away, force required would be much smaller. ये बात सबको समझ में आ रही है? पक्का? Now, here you will burn a lot of fuel. Here you will need to burn very small amount of fuel to create thrust. ये भी समझ में आ रहा है? Now, think of this. Here when you have to burn a lot of fuel, you will require a very big engine. You will require a very big engine. But here you have to burn a very small amount of fuel. Do we need that large engine? No, that large engine would be an unnecessary weight. That large engine would be unnecessary weight. It's something like here you need engine of a, let's say, aeroplane, and here you need engine of a toy car. छोटा सा जो इलेक्ट्रिसिटी से चलता है मान लो। तो if you carry this engine with you to that height, if you carry this engine with you to that height, you will unnecessarily be carrying this extra weight जिसकी जरूरत नहीं है। Did we understand this? So what do we do in rockets? In rockets we have multiple engines. We have these are called stages. First stage engine, second stage would be much smaller, third would be much smaller, fourth would be एकदम छोटा. At the lower level, first this engine and the fuel in it will burn, will create a lot of thrust. It would go up. At some height, this engine will fall down. हो गया बेटा तुम्हारा काम, जाओ. It will be removed. And on top of the fourth engine is your satellite. छोटा सा satellite का जो weight होता है ना, payload, it is very small when compared to the entire weight of the rocket and fuel. Satellite is very small weight. It is the remaining part which is heavier. Did we understand this? So after some height, this will be dropped. What will be dropped? The heavier engine would be dropped. Again at some more height, another heavier engine would be dropped. Then at some more height, dropped. आखिरी में this last engine would remain and this satellite would remain. So this rocket goes here and last में this last engine will start revolving in this orbit at a particular, because ये rocket के पास तो engine है. Here you can control at what speed will it be revolving, कितना burn हो रहा है, कितना नहीं हो रहा है. And while it is revolving in this orbit, it will slowly release the satellite. जा सिमरन जा, जी ले अपनी जिंदगी. Got it? This satellite would thus be released and it will start revolving in this orbit. If it is released at a speed of √gm/r, it will start revolving in a circular orbit. If it is released at a speed more than √gm/r, it would go in a elliptical orbit. Did we understand how rockets work? Now for us, it would be easy to understand कि PSLV has 4-stage engine, CSLV has 3-stage engine. Now you understand the purpose of engines. Why different engines? Why different capacity or capability of engines? Is this clear to all of you? Pakka? Okay. Now let's understand one more thing. We are still into the basics. When you studied PSLV, you must have seen that PSLV में हम ये बोलते हैं this is a solid engine rocket, this is a liquid engine rocket, है ना? पहला स्टेज जैसे PSLV में फर्स्ट स्टेज इज सॉलिड, सेकंड इज लिक्विड, थर्ड इज अगेन सॉलिड, फोर्थ इज लिक्विड. GSLV में फर्स्ट इज सॉलिड, सेकंड इज लिक्विड, थर्ड इज आल्सो लिक्विड बट क्रायोजेनिक लिक्विड. GSLV में तो वाई द सॉलिड फ्यूल इंजन, लिक्विड फ्यूल इंजन, इनका क्या पर्पस है? Why can't we have solid, 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 solid? Lesser fuel, lesser fuel, lesser fuel, but solid, 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 solid. Why do we go to liquid? Generally जो सबसे ऊपर वाला इंजन होता है, that is liquid engine. चाहे वो in case of GSLV हो, GSLV में as we said, we have solid, liquid, and third stage is cryogenic. Cryogenic में हमने हाइड्रोजन को लिक्विड फॉर्म में रखा हुआ है, so it is also liquid only. In PSLV सॉलिड लिक्विड सॉलिड लिक्विड, तो लास्ट स्टेज लिक्विड का ही है. तो जनरली व्हाई इज इट द केस कि लास्ट स्टेज इज ऑफ लिक्विड इंजन, एक ये पार्ट. देन व्हाई डू वी हैव दिस ड्रामा ऑफ सॉलिड लिक्विड सॉलिड लिक्विड? व्हाट इज द पर्पस? व्हाट इज द पर्पस ऑफ हैविंग दिस सिस्टम ऑफ सॉलिड लिक्विड सॉलिड लिक्विड? व्हाट आर द एडवांटेजेस, लिमिटेशंस? ये समझ लेते हैं बिफोर वी रियली गो टू real rockets, because going to real rockets would be very easy if we understand the basic concept. समझ में आ रही है बात? Okay, so let's talk about it. Solid fuel. नीचे वाले stages में we generally use solid fuel. Why do we use solid fuel? Because देखो, solid जो भी चीज होती है generally it has higher density than liquid और गैस की डेंसिटी सबसे कम होगी, फिर लिक्विड की, फिर सॉलिड की, राइट? वाटर इज एन एक्सेप्शन. वाटर जब वो बन जाएगा, आइस बन जाएगा, तो वो उसका डेंसिटी थोड़ा कम हो जाता है, तभी आइस फ्लोट्स ऑन वाटर, राइट? अवतार, आइस पानी पे फ्लोट करता है ना, क्यूब वाटर ग्लास में क्यूब डालते हो तो, है ना? ऐसे न्यू ईयर पे भी डाला था क्या? नहीं, नीट पी रहे थे ऑन द रॉक्स. ऑन द रॉक्स पे भी तो नीचे रह जाता है. अच्छा, अल्कोहल की डेंसिटी और भी कम होती है? नहीं, तुम्हारे वाले में थी. इसका वाला अपना अल्कोहल था. आई डू नॉट नो दैट, बट एनीवेज. तो जनरली solid has much higher density. Now, if you have to use a lot of fuel and produce a lot of thrust, अगर बहुत कम डेंसिटी वाला फ्यूल लोगे, you will have to store it in a much larger volume, right? तो इनिशियली सबसे ज्यादा फोर्स कब चाहिए? सबसे नीचे वाले स्टेज पे, right? तो the initial engine is generally high density वाला fuel, which is solid fuel, which provides you a lot of thrust in less volume. In less volume, it will be able to provide you a lot of thrust. Did we understand this? Pakka? But then why liquid engine at the top? सबसे ऊपर जाओगे तो why do we go for liquid engine? Now see, at the top you have to control the system. Control the system means suppose you're launching multiple satellites. You launched one satellite, then you restart the engine and go to the next level. You launch another satellite, you restart the engine and go to the next orbit. ऐसा हो सकता है. You have to do a lot of maneuvering. This maneuveration is not possible in solid fuel. Solid fuel burns at one go. आपने solid fuel में आग लगा दी, सारा solid fuel एक साथ जलेगा. You cannot control it the way you can control liquid fuel. Liquid fuel में आप पाइप बंद कर दोगे, फ्यूल आना बंद हो जाएगा. इंटरनल कंबशन इंजन, we all use vehicles, है ना? स्कूटर या फिर कार अगर आप यूज करते हो तो आप पाइप वाले मैकेनिज्म से यू इंश्योर की जो आपका फ्यूल टैंक है वहां से some amount of fuel is going to the chamber where the burning would take place, and you can switch it off, switch it on, but that you cannot do for solid fuel. Solid fuel mein you have to burn the solid fuel and it burns at one go. So where maneuvering would be required, there you go for liquid fuel. But liquid fuel have some disadvantages also. Liquid engine would be much heavier. Why? कि piping and control mechanism. Solid में क्या है? डाला, जला दिया. Liquid, a lot of control, so it is, engine becomes heavier. Engine becomes heavier. That is a disadvantage. In fact, before we go into the rockets, let's look at ये फ्यूल, सॉलिड फ्यूल, लिक्विड फ्यूल के एडवांटेजेस, डिसएडवांटेजेस, देयर आर मोर सच एडवांटेजेस, डिसएडवांटेजेस, लेट्स फर्स्ट कवर दैट. हाँ, सॉलिड फ्यूल इंजन वर्सेस लिक्विड फ्यूल इंजन. सॉलिड रॉकेट फ्यूल का की कैरेक्टरिस्टिक में, इट विल बी एबल टू प्रोवाइड यू हायर थ्रस्ट in much lesser volume, higher force to launch the vehicle. Second, less volume. Third, one time burn. This is another characteristic. The fuel would burn it one go, you will not be able to control it. वहां पे ऐसा तो है नहीं ना, अपने सॉलिड फ्यूल में आग लगाई अब कि अरे आप पानी डालो पानी डालो. You won't be able to do that. And then it produces a lot of smoke, large particles, and this smoke produces large particles when fired. जैसे pollution वगैरह भी बहुत होता है. But when you come to liquid fuel engine, liquid fuel में you can control the thrust, you can decide कितना fuel burn होना है, कब उसे बंद कर देना है. Engine can be shut down and restarted, which you cannot do in solid fuel वाले केस में, because all the fuel would burn at one go. High energy density would be there. High energy density, now please note, यहाँ पे energy density volume wise नहीं बोल रहे हैं हम, per kg of fuel. वो kg में take much larger volume to store. Per kg of propellant, it may have higher energy density. It also have higher specific impulse. This is the very important part. This is the most important reason. When compared to solid fuel, liquid fuel has a higher specific impulse. What is impulse? Impulse is this. Impulse is force into time. Impulse is force into time. Now, what is force into time? देखो, force into time like एक पर्टिकुलर अमाउंट ऑफ फोर्स कितने टाइम तक आप दे पा रहे हैं. इफ वेरी लार्ज फोर्स बट फॉर वेरी वेरी स्मॉल टाइम, impulse overall would be less. Very small force, very very small force, but for very large time, here also impulse would be less. कोई भी अगर मल्टीपल कम होता है, impulse would be less. एक बैलेंस बनाना है. तो solid fuel have lower specific impulse. They will provide a lot of force, but the time for which they will be providing force would be much lesser. Why would that be the case? Because all of it would burn at one go. Whereas in liquid engine, you can control the rate at which the burning would take place. So some particular amount of force, not as large as what is required at the ground level, what is required at the time of solid fuel, that particular amount of force can be provided for a much longer period for every kg of fuel. Now think of heights. जब आप बहुत ऊपर चले गए हो, at larger heights, what would happen? At larger heights, the force required would not be very high, but you would need to operate there for longer period for maneuvering purpose and all. Right? You would need to operate there. आपको engine बंद कर देना होगा, फिर आपको थोड़ी देर और चलाना होगा. You don't require a very large force. If you provide a very large force there, the rocket would go at escape speed and go beyond Earth's gravity. We don't want that. You want to provide a small force for a particular amount of time. So for every kg of, so this is impulse per kg of fuel is specific impulse, and specific impulse is higher in liquid. और इससे भी ज्यादा कहां होगा? क्रायोजेनिक इंजन में. This is another big advantage why we have liquid fuels at the top, और cryogenic preferably. सबसे ऊपर हम क्रायोजेनिक रखते हैं. तो PSLV में भी the fourth stage is liquid fuel stage. Why is that the case? Because you need high specific impulse, you need maneuvering. सबसे छोटा वाला, सबसे नीचे वाला स्टेज है. What is there at the lowest stage? Solid fuel. चलाओ और ऊपर भेजो, जितनी स्पीड में हो सकता है उतना पॉसिबल. Send it up. You need to control the speed, you need to maneuver, you need to do other things at the top. यहाँ पे the gravitational force is very high. You have to apply a lot of force to move away from this gravitational force. Did we understand this? देखो, these are the basic concepts which would make your life very simple. ये समझ में आया ना? Any doubt before I jump on to PSLV? You will understand PSLV like anything. ये क्या मजाक कर रहे हैं? You will see rocket science is not that difficult a science. इंडियन सर्विस प्रिपरेशन बोल रहे हैं, पोर्टल पे लाइव क्लास नहीं आ रही। अरे आज की लाइव क्लास यूट्यूब पे है ना, इसलिए पोर्टल पे नहीं है। सर हाउ आर सैटेलाइट्स पुश्ड फ्रॉम वन ऑर्बिट टू अनदर? अरे सिंपल, देखो लास्ट में, हाउ आर सैटेलाइट्स पुश्ड फ्रॉम वन ऑर्बिट टू अनदर। जो सैटेलाइट्स आर जनरली, अच्छा हाउ आर सैटेलाइट्स पुश्ड फ्रॉम वन ऑर्बिट टू अनदर, सिंपल ऐसे सोचो, दिस इज अर्थ, दिस इज सैटेलाइट। तो जनरली हम ऐसा करते नहीं है, बट फिर भी किसका मन है ये, किसने पूछा? इम्तियाज ने पूछा है, हाउ आर सैटेलाइट्स पुश्ड फ्रॉम वन ऑर्बिट। लेट्स से माय सैटेलाइट इज रिवॉल्विंग इन दिस ऑर्बिट, सैटेलाइट इस ऑर्बिट में रिवॉल्व कर रहा है, कर रहा है, कर रहा है, कर रहा है। नाउ इम्तियाज का मन कर रहा है, सर मजा नहीं आ रहा, लेट्स पुश इट ऑन दी हायर ऑर्बिट, लेट्स सेंड इट हियर। व्हाट कैन वी डू? वी कैन एक छोटा सा फ्यूल बर्न कर सकते हैं सैटेलाइट में, इसे बोले कि भाई तू लीव दिस ऑर्बिट, इंक्रीज। यहाँ पे अगर स्पीड इज अंडर रूट जी एम बाई आर, इट वुड रिमेन इन दिस ऑर्बिट। इफ द स्पीड बिकम्स इनिशियल, एक फोर्स अप्लाई किया, इफ इट बिकम्स मोर देन अंडर रूट जी एम बाई आर, इट विल गो बियॉन्ड दिस ऑर्बिट, है ना, ये वाला पास हो जाएगा। नाउ व्हेन इट कम्स टू दिस हाइट, you again restart the engine in such a manner that changes its direction, it changes its speed and becomes under root gm by r, and direction such that it became circular। हो गया चेंज। ये करते नहीं है जनरली। हाउ सैटेलाइट्स आर लॉन्च फ्रॉम प्लेन लाइक बोइंग, आएंगे उसको समझाते हैं। विभाष मेहता सर, वाई देन सॉलिड लिक्विड, हाँ ऑल्टरनेट, पीएसएलवी पे आते हैं ना, पीएसएलवी पे आते हैं फिर समझाएंगे। अभी डिड यू अंडरस्टैंड द बेसिक कॉन्सेप्ट्स? वैसे ओवरऑल क्लैरिटी आई कि वाई मल्टीपल स्टेजेस और वाई सॉलिड लिक्विड, है ना, ऐसे बहुत बड़ा इंजन, छोटा इंजन, छोटा इंजन, सबसे छोटा इंजन, क्यों? This बड़ा इंजन itself could have played a role, but it's not needed because it's too heavy. It's not needed at that height. Why solid liquid, solid liquid, इस पे भी क्लैरिटी आया। Why solid engine यहाँ पे, लिक्विड ऊपर या फिर क्रायोजेनिक ऊपर? बिकॉज लो स्पेसिफिक, हाई स्पेसिफिक इम्पल्स, है ना, एट वेरी लार्ज हाइट। व्हाट डू यू वांट? यू वांट कि थोड़ा बहुत फोर्स मिले, है ना, तो एक फ्यूल विच कैन प्रोवाइड यू फोर्स फॉर लार्जर टाइम is something that you would want, right? Please note, liquid engine also have higher energy density in terms of per kg of weight. Volume ज्यादा लगेगा when compared to solid, but per kg of weight वाले point of view से they have higher energy density, again advantage, है ना। ऊपर आपको कम weight लेके जाना पड़ रहा है when you are taking liquid or cryogenic engine. Got it? Now let's go to PSLV. ब्रेक लें क्या? हाँ ब्रेक लेते हैं। लेट्स टेक अ हाफ एन आवर ब्रेक एंड देन 7:30 to 9:30 पढ़ेंगे, ठीक है? प्लीज 7:30 पे सब लोग आके सेटल हो चुके हो ना। 7:30 के बाद जो आ रहा होगा ना, मैं पीटने वाला हूँ उन लोगों को। 7:30 तक सब आके सेटल हो जाना है यहाँ पे, ओके? अभी तक जो हमने पढ़ा उन सब में ना बहुत कॉन्सेप्चुअल अंडरस्टैंडिंग चाहिए थी। इसके आगे जो भी है, सिर्फ एक टॉपिक है छोटा सा जो आएगा जिसमें हमें कुछ समझना है, बाकी सब फैक्चुअल होगा। बिकॉज यू ऑलरेडी अंडरस्टैंड कहाँ पे स्पीड ज्यादा होगी, कहाँ पे कम होगी, व्हाट स्टेजेस, यू ऑलरेडी अंडरस्टैंड दोज बेसिक एस्पेक्ट, ओके? तो आगे फटाफट होगा, शुरू करें। तो ऑल basic concepts are done. Let us start with some of the questions on them first before we go into PSLV, GSLV. There are some past year questions also in the questions that I have listed. Let's start with question number 1. Consider the following statement: a geostationary satellite is at approximately height of 10,000 kilometers. True or false? False. Geostationary is at a height of 36,000 kilometers. 35786 है ना. तो देखो ये पास्ट ईयर यूपीएससी क्वेश्चन है. बाय दिस अंडरस्टैंड जो हमने ऑर्बिट्स पे टाइम स्पेंड किया है, इट वाज नॉट जस्ट फॉर अंडरस्टैंडिंग बेसिक कॉन्सेप्ट. यूपीएससी हैज आस्क्ड क्वेश्चंस ऑन देम एज वेल. ओके, ये एफएम ट्रांसमिशन वाला अभी हमने पढ़ा नहीं है. इट इज द लास्ट टॉपिक इन योर बुकलेट इफ यू विल गो टू इलेक्ट्रोमैग्नेटिक वेव्स. बट for now let's look at its answer. FM transmission of music is very good quality because the atmospheric or man-made noises can do little harm to it. This statement is true. क्या होता है ना, जो एम होता है एम्पलीट्यूड मॉड्यूलेशन, नॉइस व्हेन कम्स इट चेंजेस एम्पलीट्यूड. तो एम्पलीट्यूड मॉड्यूलेशन वाला सिग्नल इजीली उसमें नॉइस ऐड हो जाता है. बट जो एफएम होता है फ्रीक्वेंसी मॉड्यूलेशन इज नॉट चेंज्ड बाय नॉइस दैट मच, and therefore frequency modulation or FM channels are much more clearer. This you would be able to understand when you listen music on AM radio. AM radio तो आप लोगों ने कभी सुना नहीं होगा. FM radio, FM सुनते हो तो उसमें म्यूजिक का क्वालिटी क्लियरर होता है. तो we will understand the reasons behind it when we cover the last topic. As मैंने बोला है कि the booklet that you have got is not only for space. उसमें स्पेस भी कर रहे हैं, एस्ट्रोनॉमी भी कर रहे हैं, और हम इलेक्ट्रोमैग्नेटिक वेव्स. आई वेंट थ्रू क्लास 12 फिजिक्स वाली बुक. उसमें जो भी यूजलेस चीज़ें थी वो सब हटा के जो एप्लीकेशन बेस्ड चीज़ें हैं मैंने सब डाली हैं. तो यू विल बी एबल टू सॉल्व 50% ऑफ द इवन सब्जेक्टिव क्वेश्चंस ऑफ क्लास 12 इलेक्ट्रोमैग्नेटिक वेव्स वाला. एंड ऑल बेसिक कॉन्सेप्ट, नथिंग. मैंने आपसे बोला 9th 10th एनसीईआरटी के अलावा जो कुछ पढ़ना है वो मैं पढ़ूंगा. आप लोग बस 9th 10th एनसीईआरटी साइंस के लिए अच्छे से पढ़ो. बाकी साइंस में यू विल नॉट फील लाइक कि कंटेंट की कमी है, नंबर ऑफ टॉपिक्स कम है, ऐसा किसी को नहीं लगेगा. ये मैं प्रॉमिस कर रहा हूँ. सबको यही लगेगा कि बहुत ज़्यादा पढ़ने को है. जस्ट गो थ्रू 9th 10th एनसीईआरटी एंड दिस. तो अभी के लिए सेकंड को सही मानते हैं, ठीक है. तो आंसर हियर वुड बी बी. वी विल स्टडी दिस टॉपिक लेटर. क्वेश्चन नंबर 2. क्वेश्चन नंबर 2 कौन बताएगा? एक शुरू करते हैं, इधर से शुरू करें. किंतु बताएंगे. ए, satellite used for telecommunication relay are kept in geostationary orbit. A satellite is said to be in such an orbit. देखो 2011 में क्वेश्चन आया कि when is the satellite said to be in geostationary orbit? 1, the orbit is geosynchronous, correct. Geostationary तो geosynchronous है ही. 2, the orbit is circular, this is also correct. वो तो geosynchronous बोला उसी से हो गया. The orbit lies above the earth's equator. For geostationary it has to lie in the equatorial plane above the earth's equator. The orbit is at an altitude of 22,236 किलोमीटर. No, 35786. देखो हाइट से रिलेटेड 2 सवाल आ गए हैं. नोट लाइक डू नॉट अज्यूम कि वो सब यूजलेस चीजें थी. वो सब जो हमने पढ़ा है दे आर इंपॉर्टेंट एस्पेक्ट. नाउ जो ये 22,236 किलोमीटर है ना, ये गलत है. बट 22,236 माइल, 1 माइल इज 1.6 किलोमीटर, वुड रफली टेक यू टू अराउंड 35,000 किलोमीटर. 22,236 अगर माइल्स होता तो वो 1.6 से मल्टीप्लाई करो इसे, यू विल सी दैट यू विल रफली रीच दैट नंबर, राइट. तो माइल से किलोमीटर को रिप्लेस करके भी सवाल गलत हो जाते हैं. आर बी ऑल एबल टू आंसर इट? 1 2 3 इसमें आंसर होगा. ओके. क्वेश्चन नंबर 3. उधर कोने में कौन बैठे? आपका क्या नाम है? द लास्ट पर्सन. Tamil. Oh, are you able to understand whatever I'm teaching? Why didn't you remind me that I am not supposed to speak anything in Hindi? No. If you could have reminded me even once, I could have ensured that I don't speak anything in Hindi. Anyways, question number 3. C. Anyone else? Any other answer? D. See, force is mass into acceleration. So force will always provide you acceleration. Now please note it carefully. When a body is in motion, circular motion, does it have a constant speed? Yes. But does it have a constant velocity? No. Velocity is also associated with its direction, and its direction is changing every time. Initially its direction was this, then its direction became this, then this, then this. यहाँ पे its direction is this. It's changing. And why is this change occurring? It is because of the force which is being applied by gravity. Force is, see, gravitational force की वजह से ही हो रहा है. The change is happening because of gravitational force. Are you all able to understand this? Okay, so an artificial satellite orbits around the Earth, orbiting around the Earth does not fall. This is because the attraction of Earth provides the necessary acceleration for its motion. Fine. Acceleration which is required for it to revolve around is provided by the gravity. Let's go to question number 4. Consider the following statements about sun synchronous polar orbit. Will you try this? B. It's a type of geosynchronous orbit. No, it is a low Earth orbit. It's only possible around oblate planets like Earth. Yes. B is correct. Fourth का B. Okay. 5. Winkin आप बताएंगे? Question number 5. Consider the following statements about satellite orbit. Question number 5. A satellite in circular orbit travels with a uniform speed. Okay. A satellite in elliptical orbit changes its speed as it moves in its orbit. Yes. Both are true. Both are correct. Both are correct. C. Fifth ka C. Fifth C. Question number 6. Will you try this? Akash, nahi. Harshit, nahi. Harsh. Question number 6. Come on, Harsh. A is correct. 1 is correct. Let me look at 2. A satellite in smaller circular orbit has lower angular velocity when compared to satellites in large. No. Satellites in smaller circular orbit has higher angular velocity. वो 360 डिग्री बहुत ज़्यादा फास्ट कर ले. Smaller orbit में they cover 360 degree in 90 minutes or 2 hours, whereas the larger one takes much larger time. So smaller ones have higher angular velocity. Sorry? Yes. I do not get into detailed formula, but what is your question? Angular velocity. We're talking about velocity. Angular velocity is simple. Angle traveled per unit time. That is angular velocity. Angle. That is angular velocity. No, I'm not talking about angular momentum where all other aspects would be considered. Right? Maths optional people. Am I right? यहाँ कुछ गलत बताया क्या? नहीं पक्का? So what was the answer here? A. Question number 6. Answer is A. Question number 7. 7. कौन बताएगा? 7. Let me go to Ishrar. 7. A. 3 satellites placed at 120 degree from each other in geostationary orbit can ensure that every point on the surface of Earth can have at least one of the 3 satellites in line of sight for it. Communication satellites are put in geostationary orbit because it leads to lower latency and data loss when compared to lower. दोनों गलत है ना? One is also wrong because not every point, poles are not covered by geostationary orbit. Right? एवरी पॉइंट थोड़ा ध्यान देना चाहिए था कि इज एवरी पॉइंट एक्चुअली गेटिंग कवर्ड. पोल्स आर नॉट कवर्ड बाय जियोस्टेशनरी ऑर्बिट्स, राइट? Geostationary satellites. So 7th में both are wrong. Answer is D. Fine. Revision हो गया. That is why we are solving questions. No. That is why at the end of January you will have to solve 500 questions. मुझे पूरी स्ट्रेंथ चाहिए क्लास में. अगर 150 से कम बच्चे हुए तो मैं दे दूंगा क्वेश्चंस, कर लो खुद से. मुझे क्लास में सारे बच्चे चाहिए, ऑनलाइन सारे बच्चे चाहिए. I want that all of you should be done with your science and tech by 27th 28th Jan. आखिरी के 2-3 दिन में हम 500 क्वेश्चंस कर देंगे, है ना? तो हमें फर्स्ट से इकोनॉमी शुरू करना है. 1st of February को वी हैव टू स्टार्ट इकोनॉमी नो मैटर व्हाट, एंड देयरफॉर जनवरी एंड में वी हैव टू फिनिश साइंस. बाय फ्रॉम 15th of Feb वी हैव टू स्टार्ट एनवायरमेंट, वर्स्ट केस में 20th Feb. वी वांट दैट बाय March 15 3 सब्जेक्ट साइंस, एनवायरमेंट, इकोनॉमी विच गिव्स यू अराउंड 50 क्वेश्चंस इन द एग्जामिनेशन should be done. Current updates, will keep doing some more current updates, but please ensure that Friday, Saturday, Sunday जो ये 3 दिन हैं अभी आपके पास, the plan that I gave you in the last class, you give Friday, Saturday, Sunday to what we are doing, revise everything so that those 500 questions would be like revision in classroom again. Fine. ऐसे नहीं करना है कि आप रिवीजन बाद में करेंगे, वो 500 क्वेश्चंस बाद में करेंगे, then it would become a burden. You would never be able to do it. Okay, let's go to, so did you understand why this is wrong? Communication satellites are put in geostationary orbit because it leads to lower latency. बेटा geostationary orbit में तो latency बढ़ जाता है. Latency is time to travel. In low earth orbit latency is less. That is why we are able to use it in satellite phones, because for signal to travel, the distance that signal has to cover is very less. Whereas in geostationary orbit, when you will send a signal, it will travel 36,000 kilometers, then it will come back 36,000 kilometers. So latency is higher, not lower. Okay, let's go to question number 8. Geosynchronous होता तो हो सकता है. Let's go to question number 8. Which of the following spacecraft are placed in low Earth orbit? अभी देखो हमने पढ़ा नहीं है. We have still not studied IRNSS. We have still not studied International Space Station. But still, we already have enough knowledge to solve this question. Who's going to answer? Winkin? 1 and 4 only? Okay, see, we know GPS is in medium Earth orbit. We know IRNSS is in geostationary and geosynchronous orbit. बताया था. So 2 and 3 are definitely wrong. 2 और 3 वाले सारे हटा दो. 1 and 4. Carto map making. If we have to guess, we will guess it in low Earth orbit. International Space Station, we have already said that all human flights except the Apollo mission which went to moon are in low Earth orbit. So answer is C, 1 and 4. Question number 8. Question number 9. Consider the following about geostationary transfer orbit. Question number 9. Kim बताएंगी? Kim, would you try? Question number 9. I don't see online students attempting this question. Please try to attempt it. Please आप भी आंसर करिए कमेंट में. Question number 9. B. Incorrect पूछा है. Yes, B. 1 is correct, 2 is wrong, but पूछा incorrect है. So answer is B. Answer is B. Right? Question number 9, answer is B. Let's go to question number 10. नहीं, question number 10 में we are starting with PSLV. तो चलिए अब we will quickly cover various rockets, various satellites. It's not going to take a lot of time. PSLV, Polar Satellite Launch Vehicle, the first rocket that we are going to study. Okay, so India so far have 5 generation of rockets. Third generation was PSLV, and it is also the most important rocket that India has. Most rocket that has been the rocket that has been used the most, the rocket which has had the highest number of launches. It is PSLV. But before we go into the notes, please note the name, Polar Satellite Launch Vehicle. So this was a rocket that we developed to launch satellite in sun synchronous polar orbit. In sun synchronous, do we understand what is sun synchronous polar orbit? So in sun synchronous polar orbit, what is the type of satellite that we put? Earth observing satellite, remote sensing satellite. So PSLV was primarily developed for launching satellite which are Earth observation in nature. So you would see that PSLV is third generation satellite, which it is an expandable. I'll explain you the meaning of expandable. It was also the first Indian launch vehicle to use a liquid stage. We know PSLV first stage is solid, second stage is liquid. So it was the first rocket in India which used a liquid stage. Please note, ISRO so far has 5 generation of launch vehicle: SLV, ASLV, third is PSLV, fourth is GSLV, and fifth is GSLV Mark 3 or LVM 3. This has also been renamed as LVM Launch Vehicle Mark 3. LVM 3. These are the 5 generation of rockets that we have. Now, where is PSLV used? For launching remote sensing satellites into sun synchronous polar orbits. Primary purpose of PSLV is for launching remote sensing satellite in sun synchronous polar orbit. Do I have to explain anything here? कैसे launch करता होगा and all? Do we understand it all? Please note, if it can launch satellite in sun synchronous polar orbit, then it can also launch slightly less heavy satellite into geostationary transfer orbit. Please note, it will not go to geosynchronous or geostationary orbit. It will launch it in GTO, geostationary transfer orbit, वो जो elliptical orbit which will take it to geostationary orbit. Do we understand this? So it can also launch satellites of lesser weight, where in geostationary transfer orbit, and thus PSLV can be used for launching both Earth observation satellite as well as communication satellite. But Earth observation satellite slightly heavier it would be able to launch, but for communication satellite which goes in geostationary orbit, थोड़ा कम weight का communication satellite ये launch कर पाएगा, because for sending something to geostationary orbit, the launch speed and all those requirements are also there, which consumes the capacity of PSLV. Fine, ये समझ में आया? Okay. See, compare various satellites that India have. इसमें SLV, ASLV, these two are not used anymore. PSLV, GSLV Mark 2 and GSLV Mark 3. Third generation, fourth generation, fifth generation. Now look at the lift off weight. Lift off weight when the rocket is launched. What is the weight? 320 tons. 1 ton is 1000 kg. 320,000 kg. 3.2 lakh kilogram. Weight of the PSLV when it lifts off. And what is the weight of satellite that it carries? 1860 kg. So think of this. I had drawn a figure, no? Bigger engine, smaller engine, smaller engine. उस पे भी smaller engine, उस पे छोटा सा payload. So the satellite that it can carry is 1860 kg. Maximum heaviest satellite that it can carry is of 1850 kg roughly. Exact 1860 याद रखने की जरूरत नहीं. Remember roughly 800 kg. Because ISRO के ही website पे अलग-अलग data मिल जाएगा. Sometimes they'll say 1860, sometimes they'll say 1750 and all. But roughly 1800 kg it can launch into sun synchronous polar orbit. And what is the weight of the rocket? 320 tons. It will help you understand how much of fuel goes in there. The size of satellite is a very small fraction, 3.2 lakh tons. 3.2 lakh kgs. What is 3.2 lakh kgs? 1%. 3200 kg. It is only 1860 kg. It's 0.5% of the total lift-off mass. The satellite's weight is 0.5% of the total lift-off mass. Remaining 99.5% is the fuel as well as the other engines. Have this with you. Like to understand the role of rockets and to understand how small the satellites are and how much effort is required to launch a satellite. Then GSLV Mark II, the third, fourth generation and fifth generation will come to that. But do we have clarity on this? Now see, here we have used the term PSLV XL. Let's understand this concept of XL. हमने बोला PSLV is an expandable rocket. Did we talk about the fact that PSLV is expandable rocket? What happens is this. You see this image of PSLV? In the end, you see some more motors are attached. These are strap-on motors. Strap-on motors like these can be attached or these can be removed. So PSLV rocket in itself is called, if you only take PSLV rocket, it is called PSLV core alone. PSLV core alone, core of the rocket. If you add some more strap-on motors, then it becomes PSLV DL, PSLV QL, PSLV G, PSLV. Let me explain you this. It must be there in your notes. Just focus karo samajhne pe. It must be somewhere there. PSLV core alone. Core alone, the core rocket, no strap-on motors. PSLV core alone, core only, no strap-on motors. Its capacity is, जैसे PSLV XL का क्या capacity था? 1850 kg, roughly 1800 kg. Its capacity is only 1100 kg. Got it? PSLV G, the standard form of PSLV that we use. How is it different from PSLV core alone? In PSLV G, PSLV general standard, we have 6 strap-on motors. 6 strap-on motors. Here we have 6 strap-on motors. Did you understand this? PSLV XL may be, we have 6 strap-on motors, but 6 extra large strap-on motors. 6 extra large strap-on motors. PSLV QL have 4 strap-on motors, DL has 2 strap-on motors. You can understand सबसे ज़्यादा कैपेसिटी इसका, फिर जो 2 एक्स्ट्रा मोटर लगाने पे हुआ PSLV DL, 4 एक्स्ट्रा मोटर लगाना 4 एक्स्ट्रा मोटर्स PSLV QL, 6 एक्स्ट्रा मोटर्स PSLV G, 6 एक्स्ट्रा लार्ज मोटर्स PSLV XL. And that's why PSLV system is called expandable system. Its capacity could be expanded. Did you understand that? Initial paragraph में it was written that PSLV is an expandable, PSLV has an expandable system. Fine. Now, see, PSLV XL can carry 1750 kg to SSPO, whereas PSLV CA can only carry 1100 kg to SSPO. Low Earth orbit SSPO, है ना? So it tells you the capacity difference. Now, one more small thing that we should note is that to GTO, to SSPO, it can carry 1860 kg or roughly 1800 kg. To SSPO or to low Earth orbit, it can carry 1800 kg, but to GTO, it can only carry 1400 kg. Fine. Did we understand entire PSLV properly? Now, let's talk about its launches. PSLV was developed in 1990s. Its first launch took place in 1993, which was a failure. After that, PSLV has had no failure except one small failure in 2017, 16 or 17. So, in the entire life of PSLV, there have been only 2 failures. So far, there have been 56 launches of PSLV. Of 56 launches of PSLV, there have been only 2 failures. This is how good PSLV is. Now, latest launches were PSLV 54. PSLV C54 है ना? It is the 56th launch of PSLV. PSLV C53 is 55th launch of PSLV. PSLV C52 is 54th launch of PSLV. ये 2 आगे चलते हैं. Total launches are 56. PSLV C54 is the 56th launch of PSLV. I'll explain you the meaning of C and all when we go ahead. Did we understand this? Now, let's quickly go to, we already know solid fuel versus liquid fuel criteria. PSLV C54, current affairs पे finally आ गए हम. In current affairs class. This is current affairs, launch of PSLV C54. It was the 56th launch of PSLV. You would see PSLV C-54 successfully placed Earth observation satellite EOS-06 and 8 nano satellites in orbit. It launched Earth observation satellites and 8 nano satellites in orbit. The 8 nano satellites include ISRO ka nano satellite 2 for Bhutan, Anand, Astrocast, and 2 Thibault satellite. We do not need to remember these names at all. It was the 56th launch of PSLV, but only the 24th launch of PSLV XL. Note it carefully. PSLV mein there are number of rockets, there are number of versions, CA, DL, QL, G, XL. It was only the 24th launch of PSLV XL. This time this satellite, ISRO Nano Satellite 2, was launched for Bhutan. The main satellite that was launched was Earth Observation Satellite 6, EOS 6. इसके अलावा 8 satellites have been launched. उसमें 8 nano satellites, 8 very small satellites have been launched, and these are the satellites. This is the satellite which India has launched for Bhutan. Please note that it was multi-orbit mission. Multi-orbit mission means all the satellites were not launched in one orbit. First EOS-08 was launched. Sorry, EOS-06 was launched. Primary satellite was EOS-06, which was separated in orbit 1, and subsequently orbit was changed by using 2 orbit change thrusters introduced in propulsion bay ring of PSLV C-54. These thrusters started the engine, further went up and launched other satellites. ऐसे PSLV C-53 was launched in June 2022. We will not cover all the 56 launches of PSLV, the launches which have taken place in last 1 year. So, which are the launches which have taken place in last 1 year? 53 and 54. So, 54 we have just covered, where EOS 6 was launched. This is 53 or overall 55th launch of PSLV. Please note that this was the first commercial satellite, dedicated commercial satellite mission of New Space and New Space India Limited. New Space India Limited एक space based PSU बनाई है government ने, which is supposed to commercialize our space sector. Now, this was the first dedicated commercial satellite, means this was the first launch where all the launches were for commercial purpose. In the previous launches, there were some launches for in PSLV C-54 also there were some launches for commercial purpose, but EOS 6 was for ISRO. But here nothing was for ISRO. Here everything was for commercial purpose. What did we do here? Here we launched Singapore satellites, DSEU, EO, NewSAR, Scoop-1. These were Singapore satellites which will serve various functions of Singapore, and these were launched by PSLV C-53 with the help of their commercial arm, New Space India Limited. We will talk about commercial arm, what they do, what kind of bodies they are. ये सब हमने notes में डाला हुआ है. Okay, you see, here we have a real-time image, PSLV stage 1. See, stage 1. Stage 1 has these expandable motors only. Then PSLV stage 2, stage 3, stage 4 कितना छोटा सा है. And then look at the payload. वो ऊपर निब में इतना सा, this is the payload, this is the satellite. Rest of it is, so first it would go fall, it will be used fall, third one will use fall, it will be the fourth one which will be moving around. So this image I've taken from ISRO's website. In fact, the main image of PSLV that I had shown, I had taken even that from ISRO's website. मैं आज अब रॉकेट का मॉडल लाना भूल गया. निखिल सर ने मुझे रॉकेट का मॉडल गिफ्ट किया था PSLV का, कि सर यूज दिस इन क्लास. So while teaching this in PMP, I used it, but यहाँ पे लाना भूल गया. Else I would have given you a rocket model also to understand कि reality में what is the scope of the satellite, how small the satellite is. Now, because we have already covered the basics, I do not have to tell you what is low Earth orbit, what is SSPO, how the launch would have taken place. पहला वाला इंजन चलेगा, दूसरा चलेगा, why liquid solid, solid liquid, solid liquid. You already understand those aspects, right? Here our focus should only be on this. Then here we also did a small experiment called PSLV Orbital Platform Experiment Module, POEM. Orbital Platform Experiment Module, POEM. What is this POEM? You know, fourth stage of the satellite, fourth stage of the rocket, fourth stage of the rocket, it will start revolving in the orbit and will release the satellite. It released the satellite, now satellite is revolving, but this fourth stage is also revolving. Now fourth stage is not a satellite, fourth stage is a rocket engine. So it is not developed for the purpose of revolving there. but for 1 month or 2 months or 6 months, it will keep revolving before it gets destroyed. It will be there in the orbit. So it is behaving like a satellite for that period. So why can't on this we put some components, some cameras, some communication devices, and then experiment with them? This was done in POEM. This is not the first time we have done it. Even in 2019 we had done it. And we did it again where some of these payloads were used. Software defined radio based telemetry multimedia transmitter. So again, communicate like some what universities could do. Think of a student from IIT Roorkee developing a communication system, और उन्होंने इसरो को रिक्वेस्ट किया, इसरो प्लीज पुट इट ऑन द फोर्थ स्टेज इज रिवॉल्विंग, द कम्युनिकेशन सिस्टम इज देयर, it will be passing through India. Those people from Earth would be able to communicate with it and will be able to learn how the space sector functions, how the satellite communication functions, without any extra burden, without any extra cost. So these were some of the components which were there. Now let's come to GSLV. So do you remember that image जो हमने अभी देखा था? Let's go back to that image where comparison was there of all PSLV, GSLV and GSLV Mark III. This was PSLV XL. Then we have GSLV Mark II. Heavier. देखो, it is heavier than PSLV, much more powerful than PSLV. It has 3 stages: solid, liquid and cryogenic. It had 4 stages: solid, liquid, solid, liquid. It has 3 stages: solid, liquid and cryogenic. What is its capacity? It can carry 2200 to GTO. Geostationary transfer orbit में how much weight can it carry? Around 2200 kg to GTO, to geostationary transfer orbit. So देखो, understand, with PSLV, the maximum weight of the satellite that we could send to geostationary transfer orbit and eventually to geostationary orbit was only 1800 kg. But communication satellites were much heavier. So we needed a better satellite. So in 2000, in 1990s PSLV was developed. In 2000 we had developed GSLV Mark II. 2000 से 2010 का जो पीरियड था ना, उसमें a lot of work was done on GSLV Mark II, and 2010 से 2020 वाला जो पीरियड था ना, उसमें a lot of work was done on GSLV Mark III. Now GSLV Mark II, first stage solid, second stage liquid, third stage cryogenic. I'll explain you what cryogenic is. इसमें भी the limitation was it can only carry 2200 kg weight. But when our communication satellites which needed to go to GTO were weighed around 300 kg, 400 kg, we had to depend on foreign satellite agencies. For example, European Space Agency launched our satellite GSAT-11 which weighed around 5500 kg. Some other GSAT satellites which weighed around 3000 kg, 4000 kg, for which we had to depend on those agencies, and they used to charge us a lot of money. Okay, and therefore we also developed GSLV Mark III. Mark III is lower in height when compared to GSLV Mark II. See, it is lower in height, but weight wise it is much more larger. It also has solid, liquid, cryogenic stage, and its capacity कितना है? What is the weight of the satellite that it can carry? 4000 kg. उसका खुद का weight 640 tons है. 1 ton is 1000 kg. Am I right? 1 ton कितना होता है? 1000 kg होता है. 640 ton, 6.4 lakh kg. And what is the weight of the satellite that it can carry? 4000 kg to GTO. Please note one thing. If to GTO it can carry 2200 kg, GSLV Mark II. So to low Earth orbit it can carry much heavier weight. जैसे PSLV XL was able to carry 1860 to low Earth orbit, but to GTO it was only able to carry 1450 kg, roughly 1400 kg, right? So when PSLV was able to carry to GTO 1400 kg, so to low Earth orbit it was carrying heavier weight. In the same way, if they are carrying to GTO 2200 kg to low Earth orbit, it will be carrying much heavier weight. So GSLV Mark II is capable of carrying around 4000 kg to low Earth orbit. GSLV Mark III, ये GTO में कितना weight लेके जा सकता है? How much weight can it carry to GTO? 4000 kg. but in to low Earth orbit, how much weight can it carry? Around 8,000 to 10,000 kg. Got it? Are we understanding the various important rockets of India? Please understand these are rockets. Abhi will come to the satellites, the small part. They are also in hundreds of kgs, but they're still small. आप लोग डिस्टर्ब तो नहीं हो रहे उधर से? नहीं ना? समझ में आ गई बात? Okay. Now let's go to GSLV. So GSLV 3-stage engine, solid, liquid, cryogenic. एंड जितना फास्ट हम आज सेकंड क्लास में चल रहे हैं ना, इससे भी कहीं ज्यादा फास्ट हम कल की फर्स्ट क्लास में चल पाएंगे, बिकॉज इट वुड बिकम मोर एंड मोर फैक्चुअल, बिकॉज वी हैव ऑलरेडी अंडरस्टूड मोस्ट ऑफ द कॉन्सेप्ट्स. तो जीएसएलवी में इट्स ऑल्सो एन एक्सपैंडेबल सिस्टम. एक्सपैंडेबल सिस्टम मतलब स्ट्रैप ऑन मोटर्स लग सकते हैं. फर्स्ट लॉन्च टुक प्लेस इन 2001 बट इट वाज अ फेलियर. फर्स्ट सक्सेसफुल लॉन्च टुक प्लेस इन 2003 which carried GSAT-2. तो जैसे अपना IRS सीरीज था ना, इंडियन रिमोट सेंसिंग सैटेलाइट, PSLV was primarily developed for that. That was supposed to go to low Earth orbit for remote sensing purpose. ऐसे ही इंडिया का जो कम्युनिकेशन सैटेलाइट का सीरीज है, that is called GSAT series. That is called GSAT series. Now, what ISRO has done in recent years, it has moved on to better generic names. For example, अब जो रिमोट सेंसिंग सैटेलाइट से पहले it was called IRS, Indian Remote Sensing Satellites. Then they used some more specific names. For example, Cartosat. Cartosat satellites are remote sensing satellite, but for image processing. OceanSat. OceanSat is for observing oceans. Right? Now, ISRO has moved to more generic names. Now they are using words like EOS-01, EOS-02, EOS-02. Earth Observation Satellite 01, Earth Observation Satellite 02, Earth Observation Satellite 03, and so on. You remember PSLV C-54? What did they launch? 06. They launched Earth Observation Satellite 06. So now we have moved to generic names. In the same way, in communication satellites, we are moving to generic names. पहले हमारा INSAT series of satellite था, फिर we come to GSAT series of satellite, but now we are using words like CMS, communication satellite, या फिर और भी दूसरे नाम, बहुत जेनरिक नेम्स यूज कर, राइट. तो इट वाज डेवलप्ड फॉर व्हाट? इट वाज डेवलप्ड फॉर GSAT सीरीज. GSAT सीरीज वाज फॉर कम्युनिकेशन पर्पस. पेलोड टू GTO, व्हाट पेलोड कैन इट कैरी? देखो 2.5 टन. अभी हमने उसमें देखा 2200 kg, यहाँ पे वी आर सेइंग 2500 kg. डू नॉट फाइट ऑन दिस नंबर्स. लाइक ये अलग अलग सोर्सेस, इसरो ही अपने अलग अलग उसमें अलग अलग नंबर्स कोट कर देती है. इट्स नॉट दैट बिग अ डील. ओके, देन पेलोड टू लो अर्थ ऑर्बिट अप टू 5 टन. Again, if you go to ISRO's website, you will say sometimes they're saying 4 tons, 4,000 kg, sometimes 5,000. Understand the rough numbers. Okay. So there are 3 stages here. One solid motor stage, which is expandable. One liquid motor stage. One earth storable liquid stage. And third is cryogenic. So it is cryogenic that we want to understand. Solid liquid to we understand. देखो solid में अच्छा, by the way, नहीं एक चीज हमने मिस कर दिया. Which is the fuel that is used. So solid engine, when we say solid engine, so the fuel that is used is STPB. ये notes में नहीं है, लिख लो, because some people have a lot of खुजली, they keep asking. UPSC will not ask it, but still the fuel that is used is STPB, hydroxyl terminated polybutadiene, which is it's a solid fuel engine. So solid fuel, hydroxyl terminated polybutadiene, STPB, full form खुद देखना जिसको interest है ना? Hydroxyl terminated polybutadiene, I'm not going to write its full spelling here. In liquid engine, the fuel that used is UDMH, asymmetric dimethyl hydrazine. But again, बस उन लोगों के लिए जिनको खुजली होती है. UDMH is the liquid fuel which is used in second engine, or some other form of methyl hydrazine is used in liquid engine. Okay. Now let's come to cryogenic engine. Sorry, लॉग आउट हो गए? इसने लॉग आउट कर दिया? नहीं? अच्छा, एक सेकेंड, ऑनलाइन तो जा ही रहा है। हर्ष, ये देखो लॉग आउट हो गया। यूट्यूब पे भी बंद हो गया होगा क्या? यूट्यूब पे चल रहा होगा तो वहाँ लॉग इन क्यों कर रखा है तुमने? यूट्यूब पे सब सही चल रहा है ना? पक्का? मुर्गा बना दिया जाएगा तुम्हें। और आज तो यूट्यूब पे तुम्हारी स्टोरी बता दूंगा मैं सबको। जाओ। Solid, liquid is understood. Let's come to cryogenic engine. Now, cryo, very cold situation. जैसे अर्थ पे we have biosphere, we have atmosphere. In the same way, we have cryosphere. Which is the place which is called cryosphere? Polar region or top of the hills. Very cold temperature वाला जो region है, that is cryosphere. तो cryogenic upper stage, CUS. This is the stage where we use liquid fuel, but what liquid? Hydrogen. Now to keep hydrogen gas at liquid state, we have to keep temperature below minus 250 degrees Celsius. Imagine, minus, what is the absolute zero temperature? Minus 273. minus 250 डिग्री सेल्सियस हमें रखना पड़ता है हाइड्रोजन का टेम्परेचर, और उससे भी कम रखना पड़ता है इन ऑर्डर टू कीप हाइड्रोजन एट लिक्विड स्टेज. हाइड्रोजन इज ओनली द फ्यूल, उसके साथ ऑक्सीजन भी चाहिए होगा, तो लिक्विड ऑक्सीजन इज ऑल्सो यूज्ड. लिक्विड ऑक्सीजन एंड लिक्विड हाइड्रोजन आर यूज्ड एज फ्यूल इन द cryogenic upper stage. CUS, sometimes this term CUS would be used. It is cryogenic upper stage. It is cryogenic upper stage. What do we use? Cryogenic engine. Initially in GSLV Mark II, the engines that we used was CE 7.5. CE 7.5. So सबसे पहले initially we used engines that we got from Russia. We were not able to develop our own engines. Then by reverse engineering of Russian engines, we developed CE 7.5. So in GSLV Mark II, we used CE 7.5. Now GSLV also had variants Mark 1, ABC. They are not important, not used anymore. It is GSLV Mark II which is operational, which is used. Before we go to LVM3, please note that the last launch of GSLV Mark II was a failure. It happened in August 2021. News में लिखा हुआ होगा GSLV F10 failure. What went wrong? The third stage failed to ignite, and the rocket along with satellite EOS-03 was the satellite that was going to be launched, most likely fell off somewhere in the Andaman Sea. So when it comes to PSLV mein, we have seen ki PSLV may of the 56 launches there have been only 2 failures, but in GSLV we have not been able to perfect the engine yet. GSLV Mark II specifically, and here also the cryogenic engine, the upper stage wala thing failed. GSLV Mark II ka. So this had created a lot of issues. India is developing a radar system or a telescope, NISAR, NASA ISRO synthetic aperture radar. That it is going to be one of the most expensive telescopes to go in the space, but radar telescopes to go in the space, but it is supposed to be launched using GSLV Mark II. अब GSLV Mark II ने ऐसी गड़बड़ कर दी, billions of dollars would be lost. So NISAR का future has also become a, like, maybe we'll have to either not use GSLV Mark II or find some other mechanism for launching NISAR. We'll study about NISAR also. When we come to NASA efforts, we'll study about NISAR. But GSLV is still creating problems for us. And one of the reasons is the cryogenic engine 7.5, CE 7.5 has been developed using reverse engineering of the Russian model. But in GSLV Mark III, LVM3, initially the name GSLV Mark III was given, but now we use the generic name LVM3, Launch Vehicle Mark III. launch vehicle Mark 3. What is this launch vehicle Mark 3? Launch vehicle Mark 3 is also like GSLV, 3 stages: solid, liquid, and cryogenic stage. But all 3 stages will be much more powerful. You remember its capacity, GSLV Mark 3 can carry 4000 kg to GTO. GSLV Mark 2 can carry 2200 kg to GTO. PSLV XL can carry 1450 to GTO. We're talking about GTO, so 1400 kg to GTO, 2200 kg to GTO, and 4000 kg to GTO. So now, when our communication satellites which weigh up to 4000 kg, we do not have to depend on foreign launches, right? सही पूरी थक गई है नहीं? समझ में आ रहा है ये? This is GSLV Mark 3. अभी GSLV Mark 3 के भी launches हुए, will come to that. Now note one more thing. GSLV Mark 3 or LVM 3 is capable of carrying 4000 kg to GTO. But to low Earth orbit, what is the weight that it can carry? 8000 to 10,000 kg? Note it carefully. Now, पहला स्टेज सॉलिड रॉकेट बूस्टर है, इसमें 2:200 सॉलिड रॉकेट्स हैं, STPB फ्यूल है, इट ऑल्सो हैज स्ट्रैप ऑन मोटर्स. स्ट्रैप ऑन मोटर्स का जो स्ट्रैप ऑन मोटर्स आर लिक्विड इंजन यहाँ पे. देन अ लिक्विड सेकंड स्टेज है लिक्विड प्रोपेलेंट स्टेज. थर्ड स्टेज है क्रायोजेनिक इंजन. बट दिस क्रायोजेनिक इंजन इज नॉट CE 7.5, दिस इज C25 which has been developed by India from scratch. यहाँ पे reverse engineering and all has not been used, and therefore it has not given us failures so far. In the developmental phase, also in the commercial launch that we have started, LVM 3 में failures have not occurred. Capability we understand. In fact, this is the heaviest of India's rocket. What? LVM 3. What is its lift-off mass? 640 tons, 640,000 kg. What is the weight that it can carry to low Earth orbit? 8 tons. यहाँ सब कुछ tons में दिया हुआ है. To GTO, 4 tons. This we understand. But compare it with other heavy satellites of the heavy rockets of the world. Ariane 5, which is of European Space Agency, lift-off mass 780 tons. But GTO में कितना weight carry कर सकता है? 10 tons, 10,000 kg. What can be carried to GTO? 4,000 kg. This is European Space Agency. China, GTO में 14 tons. Falcon Heavy, SpaceX, a private company, GTO में 27 tons. NASA's latest space launch vehicle, GTO में 27 tons. So we are still behind many of these space powers, and therefore these space powers can plan for things like deep space missions, which so far we have not been able to do. फाइन, ये समझ में आ रहा है? सबको समझ में आ रहा है? कोई प्रॉब्लम नहीं है? ओके. नाउ फ्लाइट्स ऑफ LVM 3 so far. Which are the flights of LVM 3 which have taken place? Now LVM 3 और GSLV Mark 3 are the same thing. कोई कंफ्यूजन तो नहीं हो रहा बहुत? सबको समझ में आ रहा है ना? ओके. LVM 3 के फ्लाइट्स जो गए हैं अभी तक. तो सबसे पहले there was an experimental flight. In experimental flight, what did we do? Experiment में we just tested the first stage. That happened in 2014. Then it's developmental flights. Developmental flights are not actually full-fledged commercial flights or full-fledged mission mode flights. We are still in the developmental phase. Even then, some of the launches were done. GSLV Mark 3 D1, GSLV Mark 3 D2. These are the developmental launches. And in developmental launches, GSAT 9 satellite and GSAT 29 satellites in 2017 and 2019 was launched. 2017 and 18, I guess. 18, yes. In 2017 and 2018, GSAT 19 and GSAT 29 satellites, these were heavy satellites, which could not be launched by GSLV Mark 2, was launched by GSLV Mark 3. These were developmental flights. Now comes main mission mode flights when GSLV Mark 3 is properly ready. GSLV Mark 3 M1 was Chandrayaan 2 mission, July 2019. Chandrayaan 2 was launched in July 2019. That was, we will study about it in detail. how did it reach moon and how it landed, and all those things we would study. And GSLV Mark 3 और LVM 3 M2 happened अभी October 2022 में. Now understand this. When we would say अभी तक GSLV के कितने लॉन्चेस हुए हैं, तो though this number will tell us LVM M2, but launches that have taken place are 4, D1, D2, M1, M2. In the same way, remember PSLV C54 was the 56th launch. PSLV C54 was the 56th launch. The way LVM M2 is the 4th launch. LVM M3 would be the 5th launch. LVM M4 would be the 6th launch. LVM M5 would be the 7th launch. Right? ये समझ में आ रहा है? तो we'll study about LVM. Remember this पहले. D1, D2 से हमने 19 और 29 लॉन्च किया. Both these 19 and 29 are communication satellites. These are not only communication satellites, but these are advanced communication satellites which can carry, which can communicate a lot of data. Okay, these are new generation of our communication satellites. Then Chandrayaan 2 हम पढ़ेंगे. Let's talk about the latest launch, GSLV Mark 3 M2 OneWeb India mission, which was launched in October 2022. बीच बीच में करंट अफेयर्स पढ़ाने में भी मजा आता है. इनसे सवाल नहीं आएंगे. देखो सवाल आएगा किससे? बेसिक कॉन्सेप्ट से. इसीलिए while we cover current affairs, we ensure that more important basic concepts are also covered. Otherwise you will cram, इसने ये लॉन्च किया, इसने ये लॉन्च किया, इसने ये लॉन्च किया. Question would be from basic concepts. We have already seen that questions which have been asked so far. Okay, OneWeb India mission, GSLV Mark 3 M2. See, this is only the second operational flight of LVM 3. D1 and D2 were developmental flight. They were not operational flight. This was a dedicated commercial satellite mission of New Space India Limited. Again, dedicated commercial satellite means कोई इसरो का satellite launch नहीं हुआ, सब business. There's a company called OneWeb. इनके 36 satellites launch हुए. All these, each of these satellites were weighing 150 kg. तो total जो weight इसने launch किया, that is 5796 kg. Now LVM3 इसका GTO में capacity कितना है? 4000 kg. Can it carry 5796 kg to GTO? No. So where were these satellites launched? Low Earth orbit. Where would these satellites be launched? In low Earth orbit. So there's this company OneWeb. इनकी 150 plus satellites. 36 satellites of weighing 150 to 150 kg each was launched by this. Note some of the unique features of this mission M2. LVM3 M2 के कुछ interesting aspect. It is the first commercial mission of LVM3. इससे पहले GSLV Mark 3 या LVM3, D1 and D2 were those commercial flights? No. क्या हुआ था? Satellites GSAT 19 and GSAT 29 of ISRO were launched. LVM3 M1 Chandrayaan, वो भी ISRO का मिशन था. It was not a commercial mission. LVM3 M2, the first commercial mission of LVM3. समझ में आ रहा है बात? Second, first multi satellite mission. यहाँ पे 36 सैटेलाइट एक साथ लॉन्च हुए. देखो D1, D2 and M1, GSAT 19, GSAT 29 and चंद्रयान एक एक ही लॉन्च है. यहाँ पे 36 launches. First launch of LVM2 low Earth orbit. LVM3 before this have been launched only in GTO. Here for the first time we have gone to low Earth orbit. First Indian rocket with 6 ton payload. पहली बार कोई इंडियन रॉकेट है जो अराउंड 6000 kg लेके गया है. Before this, no Indian rocket has gone with 6000 kg payload. In fact, no Indian rocket was capable of carrying 6000 kg payload. GSLV Mark 2 का capability कितना था? 4000 or 5000 in low Earth orbit. This is the first time an Indian rocket has carried 6 ton payload. First NSIL mission with LVM3. NSIL the PSU पहली बार उन्होंने LVM3 के, इससे पहले they have worked with PSLV but not with LVM3. Launch vehicle Mark 3 और GSLV Mark 3. First OneWeb mission with NSIL DOS, Department of Space. तो OneWeb a private company, London based company, इनका पहला मिशन है with LVM3. और LVM3 नहीं, इनफैक्ट इंडिया के स्पेस के कमर्शियल NSIL के साथ भी पहला मिशन, फर्स्ट मिशन ऑफ. So many first in LVM3. OneWeb is a joint venture between India's Bharti Enterprise and the UK government. They want to provide a high speed, low latency connectivity worldwide, and for that they are launching a lot of satellites. 36 of these satellites were launched with the help of LVM3. Okay, so this was the latest launch of LVM3. So far what we have seen PSLV ke launches in last 1 year, PSLV C53, PSLV C54. We have seen GSLV ka last launch, GSLV Mark II ka last launch, which took place in 2021 and was a failure. We have to understand that so far we have not been able to recover from that. We have not been able to launch GSLV again, which is successful. In the past, GSLV Mark II has been successful. ऐसा नहीं है कि GSLV Mark II has only failed, but the last launch was a failure when we haven't recovered from it. Then we talked about LVM3. After COVID, this was the first launch of LVM3. LVM3 M1 was launched in 2019, Chandrayaan. LVM3 M2, this was the first launch after COVID. First commercial launch of LVM3, first launch to carry around 6,000 kg of weight, first launch of OneWeb with NSIL, Department of Space. Okay, now India's journey of developing its own cryogenic engine. Mohit is asking, sir, wood is a solid fuel. If yes, we can control the combustion, right? You can control the combustion. आप उसे निकाल लोगे कि नहीं जला रहा, पानी डाल दोगे. But consider this कि if you are given 1 kg of wood, आप उसे जलाओगे, तो unless you are directly interfering by putting in water and all, it will burn at one go. Whereas when it comes to liquid fuel, by piping and other mechanism, you can control it. Literally नहीं लेना होता. Understand the भावना. Who is भावना? नहीं. What is भावना called in English? Sentiments. Understand the emotions, understand the sentiments. है ना? Where were we? वही है, ऑनलाइन स्टूडेंट्स मिस योर फन. अब भावना तो मेरी भी हर्ट होती है, 100 से ज्यादा लोग देख रहे होते हैं, कम लाइक्स होते हैं. देख रहे हैं, लाइक नहीं करते ना लाइक लोग, तोड़ के ना. इंडियाज जर्नी टुवर्ड्स डेवलपिंग इट्स ओन क्रायोजेनिक इंजन. देखो, डेवलपिंग अ क्रायोजेनिक इंजन में व्हाट आर द चैलेंजेस इन डेवलपिंग क्रायोजेनिक इंजन? थिंक ऑफ दिस. यू हैव अ फ्यूल which is at minus 253 degrees Celsius. Imagine minus 250 degrees Celsius. And then you have to burn it at very high temperature. It involves its own complexity. Both, not only fuel, but even the oxidizer, liquid oxygen, is at minus 250 degrees Celsius, and then कुछ तो हुआ है, आ गई. अच्छा रुको, मैं ठीक कर लेता हूँ. नहीं हिलता रहता है ना. अभी आ रही है सबको? पक्का नहीं आ रही? नहीं ना, कुछ तो हुआ है. हाँ अभी ठीक है. बेइज्जती करा लो तुम मेरे यूट्यूब पे. आ रही है, जा रही है? नहीं, मैं उन्हें बता रहा हूँ, वीडियोग्राफी टीम को. क्या सही है? आवाज सही आ रही है? तुम वहीं खड़े रहो, है ना. खड़े रहो, बैठना नहीं है. चलिए, India's journey of developing its own cryogenic engine. So I have roughly told you the entire journey. Initially, when we were developing GSLV Mark II, we took help from Russia. But after a few launches, Russian engine were done. Then we were already in the process of developing our own engine. We have developed 7.5 CE 7.5, which is a reverse engineered version of the Russian engine. But उसके अपने challenges हैं. We have seen that even the latest launch was a failure. Now we have upgraded to CE25. Acha, by the way, why do we want to go to cryogenic method. Why not only liquid? Because it is more efficient and provides more thrust for every kg of propellant. It has high specific impulse, higher than even the liquid stage. Higher liquid stage से ज़्यादा है तो solid stage ज़्यादा तो है ही. And that is the reason we want to stick to the cryogenic stage. Okay. So C20 is being used in GSLV Mark II. It is an indigenously developed LVM3. जो C20 या फिर वो cryogenic engine C25 देखा था, it is the same thing. Further upgradation in November 2022, ISRO has successfully conducted a hot test of CE20 cryogenic engine. This successful hot test was at uprated thrust level of 21.8 ton for the first time on November 9 at Mahendragiri, Tamil Nadu. So in November 2022, we have tested a newer version of cryogenic engine which has much higher capacity when compared to the previous ones. This will enhance the LVM3 payload capability up to 450 kg with additional propellant loading. What they are saying कि LVM3 का और capacity बढ़ेगा with improved quality of engines, and this improved quality is something that was developed. In addition to the test, a 3D printed liquid oxygen, liquid hydrogen turbine exhaust casings were also inducted in the engine for the first time, and this was also tested. So the turbines which were used, turbine exhaust casing which was used was developed this time by 3D printing. I'll explain you the meaning of 3D printing. Okay, then this was the failure, August 2021 wala failure, which is here. So please do this. Let's come to sounding rockets. So there are three primary kinds of rockets that we have: PSLV, GSLV, and sounding rocket. Now, when we look at rockets which were developed for launching satellite, we have SLV, ASLV, PSLV, GSLV Mark II, and GSLV Mark III. These are the 5 generations that we have. Okay, but जब हम अगर GSLV Mark II, GSLV Mark III को, we keep it in the same family, GSLV. All the PSLVs are kept in the same family, PSLV. So right now we have PSLV, GSLV, and then what we also have is something called sounding rockets. Now what are sounding rockets? Now see, the rockets that we have seen so far, be it PSLV or GSLV, they have been used for launching satellites, right? They go to a height of 350 kilometers or 450 kilometers or 500 kilometers, 550 kilometers, and they launch satellites there. This is what happens. They launch satellites there. But these sounding rockets don't do that. ये बस शोर करते हैं. They are not used for launching satellites. What are they used for? These rockets are used for testing components. For example, suppose you have developed a new protection layer for your engine. So rather than using that protection layer directly in the mission mode launch, you will first do it in sounding rocket for testing purpose. So sounding rocket would be used for testing components which are of the low Earth orbit or which are of the lower atmospheric region, जो 100 किलोमीटर तक जो component test हो रहा. Or sounding rocket can also be used for upper atmospheric studies. Sounding rocket, दिवाली का rocket याद है? वो कितने height पे जाता है? 100 meters? Not more than that. 100 meters जाता होगा. These sounding rockets will go up to a height of 80 kilometers, 50 kilometers, 70 kilometers. So they'll be able to help you understand, study upper atmosphere. This is the purpose of sounding rockets. And the current series of sounding rockets that we are using, जैसे PSLV, GSLV series है, in the same way we have Rohini series of sounding rockets. Rohini series of sounding rockets. In November 2022, it was in news, ISRO's Rohini RH200 sounding rocket records 200th consecutive successful flight. Now here they don't have to launch a satellite. ये दिवाली का पटाखा जला के बोलते हैं successful flight. 200th consecutive successful flight of Rohini series. Sounding rockets are 1 or 2 stages. These rockets are also 1 stage or 2 stage, and both are solid. They are used for probing upper atmosphere, doing space research. India में जो first rocket launch हुआ था, that anywhere in the world, the first rocket is generally the sounding rocket. They'll first test how far they are able to go, whether they are able to control them or not. These are the series of sounding rockets that we have: RS-200, RS-300 Mark II, RH-560 Mark II. This is the purpose: meteorology, aeronomy. Rohini rocket family is a series of sounding rockets. Iska jo 200th consecutive successful flight which took place in November 2022, the small rocket lifted off from the launch pad at the Thumba Equatorial Rocket Launching Station at the Vikram Sarabhai Center. This was the purpose for which it was used. Then in the past, it has also, I've told you, no, to test new components, sounding rockets are used. So there's an experiment called air breathing propulsion experiment. For that also sounding rocket was used. So what is this air breathing propulsion experiment? See, right now when fuel is going, just say hydroxyl terminated polybutadiene, along with that oxidizing agent is also going. Because we need oxygen to burn fuel, right? And oxidizing agent ka bhi apna weight, it has its own weight. Oxidizing agent has its own weight. But now, sir, is supersonic rocket and missile same? Oh, please understand this. Missiles work on a similar principle to that of rockets. Please understand this. Now, therefore, when we had not signed MTCR, Missile Technology Control Regime, till that time we could not get support from Russia for developing missiles like BrahMos ka extended range. Earlier, before we had signed MTCR, Russia could not help us develop BrahMos, whose capacity was more than 300 kilometers. So they both work on the same principle. Bas rocket mein we launch it vertically, missile mein we first launch it vertically, then we make it go horizontally and then fall back. Right? किसी दिन मैंगलोर से मिसाइल लॉन्च करेंगे, कराची पे गिरा देंगे. नहीं, हम मजाक में बोलते हैं, बट बोलना नहीं चाहिए. वहां पे भी हमारे जैसे ही लोग रह रहे होंगे, है ना. ये गवर्नमेंट और ये लोग गंदगी करते हैं और उसमें कॉमन लोगों को क्यों मारना. मजाक है, इग्नोर. सॉरी, यूट्यूब पे तो क्या हुआ, मतलब गलत बोल रहा हूँ, ये बोला गलत ही बोला ना, उसने गलती मान ली. ऐसे नहीं गिराना कराची पे बम भाई, क्यों गिराना है? नहीं गिराना है. हाँ, मतलब ये पॉलिटिशियंस को, इन सबको पकड़ के मारो ना. कॉमन सिटीजन्स, कॉमन लोगों को नहीं मारना चाहिए. पॉइंट ये है. चलिए, हाँ, तो वी वर टॉकिंग अबाउट एयर ब्रीदिंग प्रोपल्शन एक्सपेरिमेंट. तो वी वर सेइंग कि विद फ्यूल goes what? With fuel goes oxidizing agent. With fuel goes oxidizing agent, because fuel burn करने के लिए you will need oxygen. Where is most of the fuel used? In the lower atmospheric region. In the lower atmospheric region, because here the gravitational force is highest, gmm by r square. Now, if most of the fuel is used here, most of the oxidizing agent is also used here. But here in the air, oxygen is available. Why not use oxygen from the air? Why not use oxygen from the air? So this experiment, air breathing propulsion experiment, here they tried to maintain a flame by taking oxygen from outside, breathing oxygen from outside. Air breathing propulsion experiment. Here they were able to maintain flame for 5 seconds. So this is an example of how experiments are being done. This was done using a sounding rocket. Are we able to maintain flame? So first we will test it for 5 seconds and then eventually we will be able to use it in long run. Fine. Now, other engine related news. ISRO's next gen launch vehicle may assume PSLV's role. ISRO's next gen launch vehicle, NGLV. ISRO is developing NGLV, which will one day replace operational systems like PSLV. NGLV, in NGLV, ISRO is looking for cost-efficient 3-stage orbit reusable heavy lift vehicle with a payload capability of 10 tons to GTO. Next generation launch vehicle will have payload capacity of 10,000 kg to GTO. It will be featuring what is called semi-cryogenic propulsion. Semi-cryogenic. In cryogenic, what do we have? In cryogenic, we have both fuel as well as oxidizer at cryogenic stage. Liquid hydrogen, liquid oxygen. Both of them have to be kept at very low temperature. In semi-cryogenic engine, the fuel that we use is kerosene. Kerosene का एक modified form isrosine. So kerosene तो can be kept at room temperature, but the oxidizer that is used is liquid oxygen. So it has to be kept at cryogenic temperature, and that's why this is semi-cryogenic engine. Semi-cryogenic engine has its own advantage. We'll come to that. We'll explain you that. But this will be using semi-cryogenic engine in the second stage, not in the third stage. Third stage में the best cryogenic engine है. Okay. It will have a simple, robust design which will allow bulk manufacturing modularity. Basically, they are saying that this new generation launch vehicle, abhi, this is just an idea. This new generation launch vehicle would be such that it would be easy to assemble. So private sector would be able to assemble it once it is designed. Okay, then let's come to semi-cryogenic engine, which is under development. What is this semi-cryogenic engine? So as I told you, अच्छा यहाँ पे आपको समझ में आ जाएगा. Basically, difference between cryogenic, semi-cryogenic से you'll understand. In cryogenic, what was the fuel that we were using? Liquid hydrogen plus liquid oxygen. Here the fuel that we want to use is isrosine plus liquid oxygen. Isrosine is basically kerosene का एक modified version, which we are calling isrosine. So isrosine can be kept at room temperature. This at cryogenic, and that's why this is called semi-cryogenic. Semi-cryogenic. Then temperature. Those are called ramjet engines. No, those are not. The test that was done, air breathing propulsion experiment, was a scramjet engine test, not ramjet. Ramjet is already something that is being used in BrahMos. It's a scramjet engine jiska test hua. Okay. Now come back to this temperature. So I have explained you, liquid hydrogen has to be kept at minus 253 degrees Celsius, which is in the case with kerosene. Weight. Liquid hydrogen would be heavier, kerosene occupies less space and more propellant can be packed. It is in that sense. Specific impulse किसका ज्यादा है? Cryogenic engine का, not of semi-cryogenic engine. Now please note, अगर cryogenic engine का ही specific impulse ज्यादा है, if cryogenic engine has higher specific impulse, then at upper stage what would be used? Cryogenic engine. But it has better thrust to weight ratio. That is, एक जो शुरू में आपको बहुत ज्यादा एनर्जी चाहिए होती है, बहुत ज्यादा फोर्स चाहिए होता है, पर like for a long time it may not be able to provide, but it will provide a lot of thrust, and thus it is expected to replace the second stage. जो अभी GSLV में second stage होता है, तो जब न्यू जनरेशन लॉन्च व्हीकल आएगा उसमें फर्स्ट स्टेज मे बी सॉलिड, बट सेकेंड वुड बी सेमी क्रायोजेनिक इंजन, थर्ड मोस्ट प्रोबेबली विल रिमेन क्रायोजेनिक इंजन. तो स्टेज देखोगे, cryogenic engine will be in upper stage, semi-cryogenic engine have been preferred in lower stages when high thrust is must have over specific impulse. Got it? Okay. Vaibhav is asking, sir, will we study this ramjet and scramjet? Yes, in defense wala section we will study. We'll study ramjet and scramjet also. Okay. Reusable launch vehicles. Reusable launch vehicles. Now, see, right now what happens when you launch PSLV, जो आप PSLV को launch कर रहे हो, in that case, first engine goes, falls back, second engine falls back, third engine falls back. Can we reuse these engines? Right now, no. These engines are destroyed so much. Even if they fall in water bodies, because of the friction of the atmosphere, they're destroyed so much that they cannot be used again. So it's something like you're using a bus to travel from Delhi to Noida, but that bus can be used only once, because by the time it comes back, it is destroyed. It can no more be used. Think of this, if this was the real scenario, then the cost of travel would have been very high. Abhi, to travel to Noida by bus, you may pay 30 rupees or 40 rupees, something like that. Has anyone traveled to bus by bus to Noida? नहीं. अच्छा, कहाँ से मिलता है नहीं? But if the bus could be used only once, बस का कॉस्ट कितना? 20 लाख में आती होगी बस एक? 30 lakhs. बस का कॉस्ट कितना? 30 lakhs, 40 lakhs. मान लेते 30 for now. 30 lakhs. In a bus there are 60 people sitting. तो per head cost will become what? 60, 30, 3 lakh, 5 से और divide करो, 3, 5, 60,000 rupees. Per head cost will go to 60,000 rupees from 30 rupees. Something similar is happening in launch vehicles. When we are launching satellites, costs are very high. Why? Because we can use the rockets only once. And therefore, a lot of work is going on in developing reusable rockets. That is, we should be able to recover engines and then we should be able to reuse those engines. Till now, several fully reusable suborbital system and partially reusable orbital system have been flown. Not in India, please note. Please understand, several fully reusable suborbital system. What are suborbital system? They will not be used for launching satellite. They will go to a lesser height and they will come back. These systems reusable have been used, plus partially reusable orbital system. Now, what is partially reusable orbital system? These are the rockets which are used for launching satellites, but all its engines are not reusable. Some of the engines are reusable. A SpaceX Falcon 9 rocket has a reusable first stage and expendable second stage. This is partially reusable. First stage they can reuse, but the second stage they are not able to reuse. Plan for the second stage of Falcon 9 to be made reusable, creating a fully reusable system, have been cancelled, with the SpaceX Starship being planned as fully reusable launch vehicle. SpaceX is earlier in Falcon 9 they were working on developing even the second stage which becomes reusable, but now they have given it up because they are developing a new SpaceX Starship which will be completely reusable. They are working on it. ISRO, if it's able to do this, it will reduce the cost of launch by 70-80%. Now please note that most of the expense in launch is of the fuel. वो तो अभी भी खर्च होगा, and that's why cost would not reduce to 1%. The जो बस वाला example है, in बस वाला example fuel cost is not that much. What is the higher cost of the vehicle? Because we are talking about smaller distance. Here think of 36,000 km, fuel cost would have been very high. Moving against Earth gravity, fuel cost would have been very high. So even then, around 80% reduction can happen. Has ISRO done anything for developing reusable launch vehicle? So yes, we have done some experiments. For example, for namesake, we have done some experiment. For example, once what we did, we launched the first stage engine and we were able to recover it. पानी में गिरा, हमने उसे रिकवर कर लिया. This is what we have done so far. So we are, this recovery is the first stage. So in May 2016, ISRO successfully test-fired its first engine-winged reusable satellite launch vehicle. In this experiment, the HS-9 solid rocket booster carrying RLV-TD reusable launch vehicle technology demonstrated lifted off from the first launch pad at Satish Dhawan Center. RLV-TD re-entered Earth after reaching a height of 70 km. It was a baby step towards developing reusable launch vehicle. बाद में और चीजें डेवलप करने की जरूरत पड़ेगी. Come to next. Reusable launch vehicle, we are not doing anything much. We have not done anything much yet. It's important, but we haven't done anything much. Come to low-cost small satellite, low-cost small satellite launchers. Let's understand this. What is low-cost small satellite launchers? To understand low-cost small satellite launchers, first understand PSLV. Remember PSLV CA, PSLV core alone. What is the capacity of PSLV core alone? 1100 kg. Core alone, सबसे छोटा वाला version, 1100 kg. What if tomorrow Singapore comes and says, I have a 300 kg ka satellite, please launch it? ISRO would say, please wait. Else it would be unnecessarily expensive, because we have a big bus. All the passengers should be full there, otherwise the cost of transportation would be high. PSLV is like a bus. So the problem is, when someone comes, we have to make that company wait, we have to make the organization wait. Further, making it is complex. A number of scientists are involved for months. For around a month, a lot of scientists would work in making a PSLV. Because PSLV can be used only once. So every time you have to make a launch, you have to create a new PSLV. You have to construct a new PSLV. So it makes system, it engages our scientists in assembly wala kaam. They're not supposed to do this. Day-to-day assembly work could be given to other engineers, could be delegated to other people. And then if it's going to take 1 month to assemble, then we are not providing quick service. It's something like, understand that experience. You are going and going to a bus stand and sitting in a bus, and then the conductor is telling you, हाँ चलेगी चलेगी रुको, and no one is coming in your bus. आप लोगों ने कभी पब्लिक ट्रांसपोर्ट ऐसे बस में ट्रैवल किया है? सबने किया है ना? ऐसे have you faced this experience? Have you had this experience? ये चलेगी 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 ऐसे करके वो आधे घंटे, अब वो स्पेशली इफ इट्स लोकल बसेस which travel, local buses which जैसे धारवेड़ा इज माई लाइक, मेरे घर से थोड़े वो हाईवे पे एक जगह है जयपुर दिल्ली हाईवे पे, तो when I take bus from there and by mistake if I get into not road transport bus but the private bus, then this person will make me sit and then will make me wait for let others come, and he would not even let you get down. भैया मैं दूसरे में चले, he would not, भैया बस चल रहे 2 मिनट दे दो 2 मिनट. And in that time you will see many of those government buses, roadways buses passing through. Anyways, so it's like a bus. What we want to develop is a taxi. 2 passengers want to go, 200 kg want to go, take a taxi and go. Right? We don't not only want to develop a taxi, small satellite launch vehicle. Small satellite launch vehicle is not only a taxi, but it's also something that can be assembled quickly. Assembled with where we not need scientists, some engineers can assemble it. So we have developed SSLV, small satellite launch vehicle, for that purpose. The Indian small satellite launch vehicle is a small launch vehicle which will serve small satellite launches. It is the smallest vehicle at 110 tons. हमने देखा PSLV, it weighed more than 3 lakh kgs. It is weighing more than 1 lakh kg. Low turnaround time. It will only take 72 hours to assemble, not months. 70 days which took in PSLV. Low human resource requirement. Only 6 people will be required to assemble this, unlike 60 people for PSLV. Cost effective. The overall cost of building SSLV will be rupees 30 crores. Capability, payload capacity of 500 kg to 500 km, unlike 1100 kg there. Then it uses 3 solid fuel stages and a liquid fuel velocity trimming module. It is ideal for on-demand quick turnaround time. There are some technological things that have been used. Why we need it? We need it because global demand of launching small satellites are going to go up. Even from within India, a number of institutions are coming up who want that their satellites should be launched, with which they should be able to study. It's the first developmental flight, not M1, M2, D1, D2. It is being developed. Its first developmental flight was launched in August 2022, and as per ISRO, it can be considered partial success. Partial success means last stages में गड़बड़ हुई होगी. The 3 solid fuel based propulsion stages function properly. However, when it came to stage when the satellite had to be set in orbit, when the satellite had to be launched, there was a glitch which resulted in the satellite being lost forever. ISRO announced that there was a malfunction of a sensor which resulted in placing the satellite in an elliptical orbit rather than in a circular orbit. It placed the satellite in 356 km into 76 km elliptical orbit instead of 356 km circular orbit. Now it has been placed in that elliptical orbit. अब देखो 76 km इतने पास तक अर्थ क्या आएगा, तो its speed will slow down eventually, it will eventually fall and get destroyed. What next? A committee was formed to study about the loss. What satellite was SSLV D1 carrying? Small satellite launch vehicle developmental program 1. It was carrying EOS-02 weighing 145 kg and Azadi Sat made by 750 schoolgirls to celebrate 75 years of independence under the Space Kids India weighing 8 kg. So this Azadi Sat was weighing 8 kg and EOS-02 was weighing 145 kg, which could not be launched. It was supposed to go in low Earth orbit. Total weight कितना था? 145 plus 8, around 150 kg. For that we need not use PSLV. ये बात समझ में आ गई? Complete clarity? Okay. Let's go to ISRO testing hybrid propulsion system. देखो, in rockets, all the development. First we covered basics of the rocket. Then we covered PSLV, GSLV, JSLV, M3. Then all other developments which have taken place, we are covering it. So that आपका current affairs भी पूरा होगा. This is a current affairs program, तो वो तो होना ही चाहिए. अभिनंदन. वेलोसिटी ट्रिमिंग मॉड्यूल जो आखिरी में ना लिक्विड स्टेज होता है एक, जिसपे वो वेलोसिटी रिड्यूस करेगा, उसे कंट्रोल करेगा, लॉन्च करेगा, दैट इज वेलोसिटी ट्रिमिंग। हाँ, वो आखिरी में एक वो चाहिए ना लिक्विड वाला कंट्रोल करने के लिए, इट्स दैट। ओके, हाँ, इसमें सब सॉलिड। लेट्स कम टू इसरो टेस्ट हाइब्रिड प्रोपल्शन सिस्टम। इसरो टेस्ट हाइब्रिड प्रोपल्शन सिस्टम। नाउ व्हाट इज दिस हाइब्रिड प्रोपल्शन सिस्टम? देखो, अभी तक व्हेन वी आर यूजिंग liquid fuel, we are using liquid propellant or liquid oxidizer. When we are using solid fuel, we are using solid oxidizer. Here fuel is solid, HTBP, hydroxyl terminated polybutadiene, but the oxidizer that we are using is liquid oxygen. देखो, eventually you need oxygen. Why carry other things? Oxygen in the form of a compound or anything. Just carry oxygen. So this hybrid propulsion system uses solid fuel and liquid oxidizer. The test was conducted for 15 seconds on a 300 mm sounding rocket motor. Advantage: it is more efficient, it is greener and safer to handle, and paves the way for new propulsion technologies for future mission. Hybrid technology would allow restarting and throttling. Why would it allow restarting and throttling? आप ऑक्सीजन सप्लाई रोक दो, ऑक्सीजन इज स्टिल लिक्विड हेयर, you stop. So a disadvantage of solid fuel engine was it will burn at one go, because what happens in solid fuel engine is we create a paste where oxidizing material, oxidizing compound and the fuel is all mixed. तो एक बार आपने आग लगा दी तो फिर oxidizing material is also there, there's nothing stopping. How do you stop? जैसे someone had asked me कि sir wood is also a fuel. Wood में you add water so that it doesn't get oxygen supply, and that is how you stop wood ka burning, right? Or you put sand on it. But here the solid fuel is already mixed with oxidizing agent. Here you won't be able to stop it, and that is why solid fuel burns at one go. Here we are saying we will not add oxidizing material in it, we will supply you liquid oxygen. So this gives an advantage of restarting and throttling capabilities on the motor. Are we all able to understand it? कैसे restarting abilities आएंगे? Sure? Restarting abilities, throttling abilities. The use of liquid facilitates throttling and control. The test paves the way for hybrid propulsion based sounding rockets and an exciting platform for vertical landing experiment for spent stage recovery. Spent stage recovery, when the PSLV has been used and is falling back, we can use this to provide reverse thrust and slow down its fall so that we can recover it. That is vertical landing experiment for spent stage recovery. The test was conducted by Vikram Sarabhai Space Center at ISRO Propulsion Complex, Mahendragiri. Fine. These are all the developments which have taken place in India in rocket engines. SLV, ASLV, PSLV, GSLV, GSLV M3, sounding rockets, SSLV. अब नया जो SSLV आ गया है, then hybrid और semi cryogenic engine के hot tests. We have also talked about cryogenic engine का जो updated version which is being tested. Okay, so every current affairs aspect related to rockets are done. Now let's go to satellites. Satellites. एयर ब्रीदिंग इज ऑलवेज बेटर. यहाँ पे भी तो ऑक्सीजन आपको कैरी करना पड़ रहा है ना. यस यस यस, हाँ, एयर ब्रीदिंग आप कर पाओ तो एयर ब्रीदिंग इज ऑलवेज बेटर. जस्ट इमेजिन दिस, नो, ऐसे ही सोचो कि यू आर देयर right now, you are taking oxygen from the air, you do not have to carry an oxygen cylinder with you. So what would be better? We being able to carry oxygen from the air, right? Now let's talk about satellites. Satellites, we know natural satellite like moon. Moon is a natural satellite to Earth. It revolves around Earth. Satellite means a smaller space-based object moving in a loop and orbit around a larger object. For example, moon is a natural satellite. There are a number of artificial satellites also. Artificial satellites can be divided into various categories on the basis of its application. First application is communication satellite. Now, what are communication satellites? Communication satellite at very basic level, for those of you who do not know anything in electronics, communication satellites are mirrors. Communication satellites are reflectors. Understand this. This is Earth, bada Earth, right? Now, Earth has a curvature. So, now see, this curvature is visible here, but think of this. If you consider the size of Earth to be this, then the size of the pole that you are creating would be a dot here, very small. And because light can travel, electromagnetic waves can travel in a straight line, it will never be able to carry information on the other side, right? यहाँ पे आप एक पोल बना दोगे, उससे सिग्नल भेजोगे, वो सिग्नल can go this on this side, but it will not be able to reach here. So जो curvature, if Earth was a plane surface, जैसा गैलीलियो से पहले हम मानते थे, right? If Earth was a complete plane, then एक टावर क्रिएट करके we could have communicated between India and USA. Electromagnetic wave from here, why send it 36,000 kilometers away when we can send it a few lesser distance in the other side? 36,000 क्यों जरूरत पड़ती? We need it because of this curvature. So what do satellites do? Satellites act as reflector. Communication satellites, you send a signal, it will reflect it. So from here, it was not directly possible to send signal here, communicate there. From here, it was not possible to communicate there. Communication satellites allowed you. So at very basic level, what is communication satellite? Communication satellites are mirrors, space mirrors. At very basic level, it is this. Now, space mirror will only be able to reflect something, but communication satellites, they act as space mirrors, but there is a receiver there, it will receive. There may be amplifier there, which will remove the noise and amplify the original signal. It will be able to store it for some time, it will be able to process it, and then it will be able to transfer it. So, moon is kind of a mirror. Moon is a satellite which can act as a communication satellite, but because it will only be able to reflect signals. But though the artificial satellites that we create, they act like mirror, but they have other capabilities also. These are communication satellites. Are we all clear about it? So, where are they used? They are used for radio, TV, internet data, and other kinds of information. Communication satellites essentially overcome the problem of sending radio waves which travel in straight lines around our curved planet. Radio wave travel in straight line, we have to send it in around our curved planet. It is what it allows it. Why do they go in geostationary orbit? Why do these satellites? Because antenna can point in the right direction. Communication satellite can also move in highly elliptical orbit. Note it carefully. Okay, in highly elliptical orbit, they will all, like on that path, on the apogee wala side, they will be available for longer duration. Now there are two types of communication satellites, passive and active. What will passive do? Passive will not do anything. It will get signal, it will send it back, reflect it. Active communication satellite will be able to do other things also. It will be able to amplify the signal, it will be able to store the signal, it will be able to remove some noise, and then it will be able to transfer it. Fine? Ye samajh mein aaya? This is communication satellite. Now if you look at communication satellites of India, so the INSAT series of satellite which started in 1983 was communication satellite. So INSAT 3A. So abhi currently in INSAT series of satellites we have 20 operational satellites which are INSAT 3A, 3C, 4A, 4B, 4CR, GSAT series, then GSAT 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 18, 19, 17, 16, 29. Then 11 is the GSAT 11 is the largest communication satellite that we have sent, 5850 kg. 5850 kg GTO में क्या हम भेज सकते थे खुद से? No. Even with LVM3 we won't be able to do that. So here we took help from European Space Agency. Okay, then note another interesting satellite, GSAT 7A. GSAT 7A is mostly for serving Air Force. 70% of its capability would be used for serving Air Force. Rest of it would be serving military and Navy. Then GSAT 31 was launched in February 2019. देखो यहाँ पे 19 and 29 were by LVM 3 D1 and D2. Launch vehicle Mark 3 D1 and D2 देखा था हमने. They launched GSAT 19, GSAT 29. Okay, now INSAT system have more than 200 transponders. What are transponders? And transponders in the C, extended C, KU bands, etc. Now, what is this may confuse you a bit. It's not that difficult. See, we will cover electromagnetic waves in more detail in future classes. But थोड़ा सा briefly समझ लेते हैं. Electromagnetic spectrum को. See, light is electromagnetic wave, है ना? But electromagnetic wave of wavelength of 400 nanometers to 700 nanometers is light, visible light, which our eyes can observe. But then there are wavelengths of meter, miles में भी होते हैं wavelength, तो कई किलोमीटर में wavelength होते हैं. And there are wavelengths which are much smaller than nanometer, है ना? There are these electromagnetic waves also. These are radio, micro, infrared. फिर visible आएगा. This is visible. Then we have ultraviolet, X-ray, gamma rays. These are the 7 broad categories, 1, 2, 3, 4, 5, 6, 7, in which electromagnetic spectrum is divided. Broad categories. पता है, radio waves and microwaves also. Basically, the categorization is not strictly divided on the basis of wavelength, but it is primarily divided on the source and application. अगर हम रेडियो कम्युनिकेशन के लिए यूज कर रहे हैं तो वी कॉल इट रेडियो वेव, इवन इफ वो स्लाइटली माइक्रोवेव वाले फील्ड में जा रहा है. ओके, बट रेडियो वेव, माइक्रोवेव, इंफ्रारेड, विजिबल, अल्ट्रावायलेट, एक्सरेज, गामा रेज, इसमें से जो रेडियो एंड टीवी कम्युनिकेशन के लिए यूज होता है दोज आर रेडियो वेव्स. एएम सुना है आपने? एएम, एफएम, दोज आर they use radio communication. Microwaves are used for satellite communication. Now microwaves में भी ना, जैसे यहाँ पे 400 nanometer to 700 nanometer, there are different bands, no? Right? You have violet, indigo, blue, green, yellow, orange, red, with your different. In the same way, this microwave is also divided into L band, C band, K band, KU band. We'll study about all those things tomorrow आपके इस electromagnetic wave के आखिरी वाले सेक्शन में. तो communication purpose के लिए when we are using microwaves, the devices that will develop would specialize in those bands. These are those bands which are mentioned here. C band, extended C band, KU band and so on. L band, S band, ऐसे बहुत सारे bands होंगे जिसमें these transponders would be specialized. ट्रांसपॉन्डर एक तरह से ना, फॉर नाउ अंडरस्टैंड इट लाइक दिस, एब्रीविएशन है ट्रांसीवर्स रिस्पॉन्डर्स का. रिस्पॉन्ड कर रहा है, रिसीव कर रहा है, ट्रांसफर कर रहा है सिग्नल. ट्रांसपॉन्डर्स आर दैट. फॉर नाउ ये समझो. विल गो इनटू इट्स टेक्निकलिटीज. INSAT 7A is same as GSAT 7A? नहीं, it is GSAT 7A which is used for Air Force purposes. Okay, now GSAT 7 was also a dedicated military satellite which was perhaps used primarily for Navy, है ना? GSAT 7 और GSAT 7A को निकनेम भी दिया है, किसी को याद है क्या? Angry Bird was GSAT 7A and GSAT 7 was, उसका भी कोई नाम था. चलिए एनीवेज, So 7, why 7A name was given? Because 7 was dedicated for military. 7A has been dedicated for Air Force, again military. Okay, did we understand the communication satellites? Okay, recent launches देख लेते हैं communication satellite के. As I was saying, now that INSAT series, GSAT series, those have been done away with. Now we use more common names. So, for example, communication satellite 01. CMS 01 is a communication satellite envisaged for providing service in extended C-band and frequency spectrum. It is a 42nd communication satellite of India. GSAT 7A, Angry Bird ऐसा लिखा हुआ है. GSAT 11, the largest and heaviest of our communication satellites launched so far. It was launched using Ariane 5 rocket of European Space Agency. Now we'll come to Earth observation satellites. Yes. रुक्मिणी थी क्या GSAT 7? एक बार फिर से वेरीफाई कर लेना. मैडमैन बोल रहा था, मैडमैन की बात तो ऐसी नहीं मानते. नाम उसने मैडमैन रखा हुआ है. यस, नितेश. हाँ, लेटेंसी तो रियल टाइम कम्युनिकेशन नहीं हो पा रहा, पर ऐसे तो कम्युनिकेशन तो हो रहा है. हाँ, वो ओवर करके बात कर ले. एंड इट्स नॉट ओनली दैट कम्युनिकेशन. देखो, टुडे मोस्ट ऑफ द कम्युनिकेशन हैपेंस थ्रू फाइबर ऑप्टिक्स, है ना. बट व्हेन दैट वाज नॉट अवेलेबल, थिंक ऑफ दैट सिनेरियो, दैट सिचुएशन. ना, communication was still, satellite communications was still taking place, no, है ना. Then understand something else. Understand it like this. Suppose TV communication has to take place. A movie has to be broadcasted from 3 p.m. Can you plan it beforehand and broadcast it using satellites? Yes, you can. जब दिल्ली दूरदर्शन पे टीवी देखते थे, एंटीना घुमा के सिग्नल वो करते थे. That is also communication. Do not think कि communication is only hey baby how are you, है ना. नितेश वही सोच रहा है कि रियल टाइम होगा नहीं, मैं बात कैसे करूंगा. तो कम्युनिकेशन में देयर आर अदर एस्पेक्ट्स आल्सो. बेटा, सैटेलाइट फोन्स तो आप यूज कर ही नहीं सकते वैसे भी. अभी आप सैटेलाइट फोन्स यूज कैसे करोगे? आपका जो ये छोटा सा फोन है, इट कैन नॉट कम्युनिकेट विद सैटेलाइट. आपका जो छोटा सा फोन है, व्हेन यू स्टार्ट यूजिंग डेटा इन इट, डेटा विच कम्युनिकेट्स विद द नियर बाय टावर, आपका बैटरी ऐसे गिरने लगता है. द टावर इज 1 किलोमीटर अवे, 2 किलोमीटर अवे और 3 किलोमीटर अवे, एंड यू आर सेइंग कि आप अपने फोन से सैटेलाइट विच इज 500 किलोमीटर अवे उससे कम्युनिकेट. अभी योर फोन्स आर नॉट केपेबल ऑफ डूइंग दैट. इसने Apple has come up with some satellite communication system that I have to study how is it functioning. If you see military, when they use satellite phones, they also carry a big device on their back which is communicating with the satellite, है ना. You want to do that? Baby, I'm fine. Over. बाबू ने खाना खाया? Over. बाबू ने खाना नहीं खाया. संतोष सर की क्लास चल रही है अभी तक. आप लोगों का डिनर का टाइम भी अफेक्ट होता है क्या? अच्छा है, थोड़ी भूख लगनी चाहिए, खाने की भी और सिलेक्शन की भी. ब्रेक में क्या किया था फिर? 4 पराठे खाए थे. चलिए, लेट्स कम टू अर्थ ऑब्जर्वेशन सैटेलाइट. व्हाट इज अर्थ? सिंपल अर्थ ऑब्जर्वेशन. अब अर्थ ऑब्जर्वेशन को ऐसे समझो, ऊपर कैमरा रखा है, it is taking pictures. So visible light में that will be earth observation. But earth observation can be, the visible light is something that we are able to see, but earth observation can be done in many other ways. So remote sensing, दूर से अर्थ को देख रहे हैं, that is earth observation. Earth observation satellites are specifically designed for earth observation from orbit and are used for environmental monitoring, meteorology, map making, etc. Most earth observation satellites carry instruments that should be operated at relatively low altitude, and that's why it go in low earth orbit. Earth observation satellites of India देखेंगे आप. It started with Indian remote sensing 1A in 1988. ISRO has launched many operational remote sensing satellites. Today India has one of the largest constellation of earth observation satellites, जिसमें we have EOS 0 and EOS 02. EOS 06 का ही launch fail हुआ ना? नहीं, वो launch हो गया, sorry. फेल किसका हुआ था अभी? 2 का. EOS 02, हाँ 3 का फेल हुआ है ना. SSLV के साथ व्हाट वाज गोइंग? चलो जो भी है, राइट. तो रिसोर्स सैट नेम इटसेल्फ इज टेलिंग यू व्हाट इज द नेम टेलिंग, इट इज फॉर ऑब्जर्विंग रिसोर्सेज. Cartosat, map making, Cartosat 1, 2, 2A, 2B, etc. Cartosat 3, it was launched in November 2019, more advanced version of this Cartosat 3 could give you more detailed images. Earlier you could recognize, identify that there's a human being. Now you'll be able to even identify the footmarks using Cartosat 3, the most advanced version. ये radar imaging satellites, radar imaging satellite 1, 2, 3, 2B and so on. OceanSat, Megatropic, Saral, ScatSat. These are for observing. Say Megatropic. Megha is badal, and tropics is named for that in French. So it's a collaboration between India and France. HISIS, Hyperspectral Imaging Satellite. Hyperspectral Imaging Satellite. Now see, when we talk about the quality of image, we basically talk about, say, there are images which are black and white images. Then there are colored images. In color, they are able to identify different spectrum, give you exact colors. Hyperspectral, वो और भी ज़्यादा डिटेल में स्पेक्ट्रम को डिफरेंशिएट कर सकते हैं. This would give you more advanced things. Please note, Earth observation satellite, there are some Earth observation satellites in geostationary orbit also. Geostationary से भी Earth observation किया जा सकता है. It won't be as clear as this, but EOS-03, it could not be put in orbit due to failure of GSLV F10. हाँ, EOS-03. INSAT 3D, INSAT 3DR, Kalpana and INSAT 3A. These are the satellites which are in geostationary orbit but are used for Earth observation. अब देखो, when we have Earth observation satellite which is every 90 minutes taking one round, then it will give you images, but वो फिर in 24 hours it will pass through India once and will be able to give you some images. If you want a satellite which is focused on India forever and is taking image of India forever, where would you want to put it? In geostationary. Then there are Earth observation satellites. अच्छा, ये तो हमने करा. और some recent launches, जैसे जब हमने अभी we spoke about PSLV C54, 56th launch of PSLV, it had launched what? Earth observation satellite 6 or OceanSat 3. What will this do? OceanSat 3 के बारे में कुछ और देखिए. It was placed in polar orbit at a height of 740 kilometers, weight of 1100 kg. For the first time in the series, it houses ocean observing sensors, ocean color monitor, sea surface temperature monitor, KU band scatterometer. So do you understand? For Earth observing oceans, various advanced components are there. Then let's go to here. You will see that they'll be able to, all this thing will improve the accuracy and is expected to provide improved accuracy in daily monitoring of phytoplanktons having wide range of operational and research applications including fishery resource management, ocean carbon uptake, harmful algal bloom alerts and climate studies. Fine, let's go to radar imaging satellites. ISRO's RESAT satellite makes re-entry into Earth's atmosphere. Re-entry into Earth's atmosphere का मतलब क्या होता है? खराब होने वाला है, गिरने वाला है. If something re-enters, so ISRO's RESAT-2 satellite launched in 2009 has made an uncontrolled re-entry into Earth's atmosphere. ISRO said that the satellite weighing about 300 kg made an uncontrolled re-entry in the Indian Ocean near Jakarta on 30th October. This satellite was launched using PSLV in 2009. Initially, it was designed for 4-year life, but it has served for almost 13 years. There is no contamination and no explosion since there were no fuel left in the RESAT. Because there was no fuel left, we could not start the engine and send it to higher orbit, and that's why it fell. No fragments hitting Earth. Various studies confirm that pieces generated due to aerothermal fragmentation would not have survived re-entry, heating, and hence no fragment would have impacted the Earth. तो RESAT अभी हमारा एक recently re-enter हुआ, finally destroy हो गया, किसी को कुछ भी impact नहीं किया. RESAT 2. Sorry, SatNav कल से करते हैं. देखो, let's understand SatNav so that जब रात में लेट हो जाए आप अच्छे से नेविगेट तो कर पाओ। कल से करें? नहीं चलो 9:30 हो गया है, कल से ही करते हैं, ठीक है। पर अब जल्दी हो जाए, आपको समझ में आया कि ये बिकॉज वी हैव ऑलरेडी अंडरस्टूड द कॉन्सेप्ट, तो इट वोंट बी टेकिंग अ लॉट ऑफ टाइम। डे आफ्टर टुमारो विल स्टार्ट न्यूक्लियर साइंस एंड डे आफ्टर टुमारो मतलब ऑन संडे विल डू न्यूक्लियर साइंस इन द फर्स्ट हाफ एंड रोबोटिक्स एंड नैनो टेक्नोलॉजी इन द सेकंड हाफ. Robotics nano technology will take 1 hour each. Okay, चलिए, I'll see you tomorrow then 5 p.m. Thank you.